Time for some audio tests. We are starting from scratch today. Audio test. This is an audio test. Okay. I think that's good enough. All right, let's check the YouTubes real quickly. Make sure there's no audio leakage. Let's check. That sounds good. Sounds real good. I don't care who you is, that sounds real good. All right. Where do we begin? So I've been doing a lot of C++ on this stream, but a lot of it has already been kind of set up and configured to the point where I can just compile my code and run it, and it will work in a browser, on my desktop, in a Linux environment, a WSL Linux environment, Docker container, Android app. I even showed off an example of Pong running on my phone. So I've done a lot of this, but I never really did a how-to video. I've never gone through all the steps it takes to get a nice, robust cross-platform project where I can clone it, check it out onto my desktop and compile the code no matter which desktop I'm on. And also, more conveniently, at least on Windows, be able to check it out and through a dev container, build to all the different targets that I need to using C++. So I think that's what I'm going to do today or this evening is try and get from scratch, mostly scratch. I'll show all the tools I'm installing, or I'll try to remember to, but from scratch, how to get a C++ environment using CMake, using Ninja, Visual Studio, Clang, GCC, what have you. Get that up and running and compiled. And I think we'll just do a simple Hello Triangle app using probably Raylib. Raylib is pretty easy and straightforward to do. All right. So, first things first, my Windows environment is not starting from scratch, but if you were happen to start from scratch on Windows, you're going to need a couple of tools to get installed so that you have them on hand. A compiler, CMake for cross-platform configuration, and Ninja, which is a cross-platform build tool. And the reason we're going to use Ninja is to enable consistency across all these platforms. So that way, when we're going to configure, build, etc., we'll do it the exact same way for every platform. So step one is Visual Studio. I'm not actually used 2026. Maybe this is a good opportunity to try it. Copy workloads, components, settings from our previous installation. I'm going to select manually just so I can show the different components we're going to need to install with Visual Studio. And we're going to need this C++ develop. Oh my gosh, this tooltip. Desktop development with C++. I don't know what the implications are with VS Code and CMake. So I've not had 2 instances of Visual Studio installed on my computer before. But that's okay. We'll figure it out. I'm sitting here watching this, and I imagine this is where I fast forward when I go to edit this video. My computer is cooking with this, all the video recording I'm doing. Ooh, I should probably check on that, make sure it's actually recording. Gotta be careful. I'm gonna run up. Recording the camera. I don't see it recording. Oh no. Filters. Oh, man. All right, so this is recording. I gotta remember that. It's recording in user fun and videos. Desktop. User. Videos. Okay, it's right there. So as long as it's being recorded, I can work with that. Okay, so once Visual Studio is installed, we're done with this. I guess we could launch. Oh, I hit the wrong one. That's awkward. Let's close that. Try again. All right, so once it's done, we can launch 2026. Set it to C++. Start. I like to pin this. Okay. So then we can close that. Close this. Now the next thing we go to, CMake. Kind of wish I don't think I have any. We don't. Okay. Do 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 do. Okay. I have CMake. Now I want Ninja. All right. So we have Ninja installed now, and we can verify by doing Ninja version CMake version. So that's good. So we have Ninja, we have CMake, we have Git, or we don't have Git actually. We need Git. Git. Install for Windows. Click here to download. Download. We're just going to use default settings. I don't know how to close these. This is awkward. What do I do? I wanted to show an example of installing Git. Do I have to kill Git? I don't have Git running. Oh, I see. It's right here. So we get a kill. It's probably because of VS Code. You know what? Screw it. I'll just say Git was installed successfully. And then we come in here and we do Git version. And we're good. We have Git. All right. So now that we have CMake, Visual Studio, Ninja, Git, we need to make sure our WSL environment is good. And we are good. We have Docker installed. If we didn't have Docker installed, we would come in here. And we would go into install Docker Engine on Ubuntu. Make sure you consider the following security implications of firewall incompatibilities. We want Ubuntu Noble 2404. We'd paste it. What else? What do we do? We'd copy, paste. Install the Docker packages. We'd copy. And at this point, I think we paste. And then sudo system ctl status docker. Type my password in. Hopefully this isn't leaking anything. I don't think it is. Okay. So then we do sudo docker run hello world. Hello from Docker. Okay. All right, so now we have that. I think we are good to go. So we are going to head on over to GitHub. You'll create a new repo. And what do we call this? What do we call this repo? We call this CMake cross platform. CMake platforms. Awin platforms. I don't know what to call this. CMake platforms it is. All right. This project provides examples, provides CMake configuration examples for configuring your C++ project. Ugh, I hate it. This project provides a cross-platform collection of toolchain configurations to build your project on any system. Something like that. We'll make it public. We will add a README. We will make it a C++ ignore. We will make this MIT license. Describe what you want to, we'll create the repository. Cool. CMake platforms. So we come in here. We will copy. Clone repo from GitHub. We are in. All right. So where do we even begin, right? Hello world, I think. Let's start with hello world. So if I want to write some C++ code and run it, I need a folder that I'm going to call app. In that folder, we're going to define a CMake list.txt and main.cpp, and we're going to write some code. Include print auto main int standard print line hello world. Return exit success. Cool. But how do we actually get it to compile? Well, we need to define a project, call it hello world. We need to add an executable. We need to give this guy some source code to compile to that executable. All right. That's not enough. We still need to tell this thing to like tell CMake that this project exists. So we're going to need a root level CMake file. And this is going to be like CMake minimum required version 4.3, for instance. Well, we don't really need 3.31, I think I'll say. And then we will call this project, except this isn't Hello World. This is called project CMake platforms. We'll add a subdirectory called app. And that might be all we need to get this to compile. So part of what we're going to do here is use, well, okay, so I guess one thing we can do is go into our terminal here, new terminal, and do CMake, gosh, it's been a minute, -s for source, -b for build, just run it. And that worked. So then we do CMake --build, build. And that didn't work. Right. Printline is not a member of STD, so printline is not a member of STD. So back in here, we want to say set CMake CXX standard 23. Set CXX standard required. Set CMake extensions off. So then we'll do this again. Except I actually want to configure. And it built. So from here, I should be able to do ./build app debug hello world. Success. Hello world. But that only works for Windows. We want a solution that works for everyone and configures the exact same way. And we want to do it in the expected modern way of handling CMake configuration and supporting all these different platforms. With really the long-term goal here being that no matter which platform we build for, we're providing the same similar configuration inputs. And another thing we can do is we can go into extensions and grab the CMake and the CMake tools. Make sure it's installed. Because then I should be able to... Not yet. Okay, so then with that installed, I want to make CMake presets.json. Okay. Now this is where I'm probably going to need to pull up some copy and paste because I don't remember all this off the top of my head. So I'm going to need the Windows platform, which includes binary directory. I don't want that yet, do I? Ninja. Okay. This is under configure presets. All right, we want to set up multi-threaded processing, make it restrictive. We set that up for MSVC. And that probably gets us almost all the way there, actually. I don't think there's anything here I need to show off right now. No. Let's see, the target platform. I don't need to show that off yet. Host, target compiler. That's taken care of. We have a binary directory. Oh no, the binary directory is preset name. I also want to set this. CMake install prefix. Okay. Then debug. Ooh, I need a CMake build type, which I already have. We have Ninja. All right, so I think that's all we need. And then I need to define a, let's see here, Windows platform. Need to define a build preset. All right. So with that set up, I should now be able to Control Shift reload window. Now we have access to the CMake extension. Before we build, we can, no, yeah, we can just build. So now I can do /build /x64 Windows app hello world. Boom. Now we have hello world. Perfect. So now we can make this not just do debug, but we can also have this do release. So if we want to do that, I also want to kind of clean this up. All right, so now we want to do a release preset. So we copy, paste, release, make this release, make that release. Nope, that's not what we want. Paste, release, release, hit save. So then when I come in here, I now have a release build. So then I can come in and compile. Come into terminal here and do /build /x64 Windows release app hello world. Boom. Perfect. So now we have a hello world executable working on Windows for release and debug using CMake configuration. And we don't just have to use this extension. There's nothing stopping us from, deleting this and then running this ourselves, saying CMake preset x64 Windows MSVC debug, hit enter. Oh, that's awkward. Oh, I forgot. Okay, so we'll cut that part out. You have to be in the native command prompt. Am I crazy? Why is that not working? I'm in command prompt. Gosh darn it. All right, hello world. All right, we did it. All right. So now what else can we do to clean this up? So there's a lot of duplication going on here. So I might instead do something like name this, what do I name this? Jesus. All right, so we'll give this a name. We'll call this binary dir. We'll make it hidden so that it doesn't show up. Then we'll say the binary dir is our source dir build slash preset name cache variables. We can go ahead and say cmake install prefix is source dir build preset name installed. Okay. So we do something like that. So then we don't need to do a binary directory here. We don't need the install prefix. We don't need the binary directory here. We don't need the install prefix. Instead, what we can do is have this guy inherits binary dir. Inherits binary dir. So if I delete, I'm gonna cmake. Ooh, that's awkward. I screwed something up. Do I have to put that in a specific order? I bet I do. Okay, so maybe I have to do it after name. Reload the window. Sometimes you have to reload the window. Oh, hey, Rhyme me RC. Hi, Rhyme. How's it going? Have I considered using pre-make? Not for what I am doing right now. I am building up kind of a tutorial video of how I do cross-platform development on Windows, Linux, Android, iOS, Mac, browser. What else have I done? Raspberry Pi, I guess, like ARM systems, and how I do it professionally. So I am showing exactly the way I run my teams, essentially, and what I expect my developers to do when developing cross-platform C++. And the reason CMake is at the forefront, I will go over later, but it's kind of become the de facto project configuration for modern C++, especially when you start pulling in package managers like Conan and VC Package. All right. So let's see if that fixed my syntax error. There we go. So now I can select a Windows debug build. It's going to configure and build. All right, it configured. I can build it. Perfect. And now we can do /build x64 debug app hello world and run it. There we go. We got hello world for debug, and then we can also select release. It will configure for release, generate, and then we can compile it. /build x64, except now we can do release app hello world. We've got it running for release and debug. No, I know CMake is industry standard. I just wanted to know what someone with experience thinks about pre-make, if it's even consideration. I don't know. Okay, so first and foremost, I have not used pre-make. So I can't, with any guidance, say it is like terrible, it's not the way to go. What I can say is, with my experience with CMake and the ecosystem that I always find myself in, everything I've ever needed uses CMake, and so it makes it easy for me to pull in other software dependencies with CMake. Now, part of this, I've been using CMake my entire career. So I think CMake's on version 4.3, something like that. And I've been using CMake since 2.6, 2.4, something like that. So like I've been using CMake for over 15 years. And I haven't had a need to try anything else, professionally speaking, because everything I've ever used CMake. So that's a lot of open source projects on GitHub, big name projects like Qt Framework. Qt Framework actually changed from their own custom build system to CMake in version 6. And then VC Package came around about, I started using VC Package around 7 years ago. I think it came around a little before then. And they basically started using CMake. So having like Microsoft back all of that has made it to where I've just never had to switch or try something else. So I won't say for sure if one is necessarily better than the other, but other than CMake is probably the most, what's the word? Prolific? That's not a word. What's the word I'm trying to say? I don't know. It's the most common. Okay. So now that I have that working, I still want to reduce the amount of duplication I have going on here. And I'm going to keep reducing that until we turn this into composable configuration so that we can build all of our other cross-platform configurations with this. So now that I have the binary directory pulled out, I want to pull out a debug. Actually, what I call this thing? I just call it debug. I don't like that. We're going to call this config. Config binary. Config debug. We make it hidden so that it doesn't show up in our preset configuration options. And now with debug, all we're really doing is defining some CMake cache variables. What am I doing wrong here? I am in the wrong section. There we go. Ooh, I gotta get my auto formatting turned on. Let's turn that on real quick. I'm gonna create a .vs code file, and in here we'll create a settings.json. In settings.json, we're going to do editor.format on save is true. And the other thing I don't like is having CMake auto configure. Configure on open is going to be false. CMake.configure on Edit is going to be false. I want to configure CMake when I choose to, not when it decides. Oh yeah, QRT, you've probably experienced it the same way I did then. CMake has come a long way, but unfortunately, at least from like the industry side of things, from what I have observed, not everyone is afforded the option to, uplift all of their software tools and frameworks, right? So you still have people stuck with like, I don't know, GCC 4.8, whatever started with C++11, and whatever CMake you have with that, which is probably what I was saying, like 2.6 or something. You have a lot of people out there who work in labs that don't have internet connections, right? And so, and maybe for security reasons, they just aren't allowed to change what's running on those systems, which isn't really an issue as much these days. I think there's been a lot of push to get CMake or C++ uplifted because of security issues. But it's surprising, like what you can run into out in the world with a lot of developers. Companies don't want to pay for it, right? Like, hey, it works. Why do we need C++, 14? Why do we need C++ 17? Why do I need to change how I write my CMake? It works, right? Well, the problem is for me, who is more interested in cross-platform ecosystems, getting it to work for one platform is a lot different than getting it to work for all platforms. And so what I am walking through here is my process for getting C++ to compile and run for most platforms. I'm not going to say all platforms, most platforms. Most user-facing platforms, if you will. And what's kind of cool, I was just reading about this the other day, and I didn't realize this, but I guess Kitware, the people who make CMake, Microsoft, VC Package, the Conan Package Manager, and I think there's a handful of other companies that are backing this, but apparently there is a push to create a common, it's called CSP, common, actually I could just pull it up, hang on. CMake CSP? Is it CSP? I'm going to accidentally Google something while streaming and it's going to look... Cross-platform tool? No. No. Is it C... Oh my gosh, this is going to drive me crazy. CMake Common Platform Standard. No. Oh, this is going to kill me. I swear I was just reading this the other day. And I think CMake even had news on it. But anyway, they're coming up with a way to where projects... they're coming up with a standard way for projects, C++ projects, to produce package artifacts. So what I think that means is you're not necessarily going to have to rely on Conan or VC Package to get what you need. It's because they're standardizing on this, it's going to be like, hey, as long as you build your project and produce these outputs, then any other project should be able to pull it in. Not unlike, again, heavy assumptions here, not unlike more modern languages where they are like building the package managing ecosystem into their language. Gosh, I don't remember what it was called. But I was just reading about it. Cross-platform packaging system. Cross-platform packaging system. CMake contains the CPAC... No. All right, whatever. I tried. It's out there somewhere. I don't remember what it's called. I think it's like people are working on it, actively developing it. Okay, so I want to config debug, config release. So by doing this, and the reason I'm pulling this stuff out is we'll eventually see, but I'm turning these presets into composable pieces so that I can reuse them for other platforms and configurations. That way, I don't have to keep rewriting this, because otherwise these CMake presets, before I learned you could do this hidden trick, I would have like thousands and thousands of lines of presets, and it was just so hard to like track down what was happening, how to like where I needed to go to edit something. You misplace one comma and it's like somewhere in 1,000 lines of text. Even this is getting out of hand, and I already have a syntax error. It's telling me preset. Oh, binary. That's right, because I renamed it. Config. All right. So now that I created these config, debug, and release presets, what I can now do is put this in here and remove this cache variable. Put the release in here. Remove this cache variable, and then I can just verify that everything is still looking good. Common package specification. Thank you. I said it wrong. I was looking for CSP. It was CPS. You're a lifesaver. But yes, I think there is some big name tools and companies behind this pushing for it. I'll tell you, CMake, C++, package managers have come a long way since I first started doing development. Having to maintain your own third-party dependencies and then having to rebuild them or update them when, like, because we didn't have GitHub back then, or GitHub was like, or the tools that were on GitHub were few and far between compared to today. And so, like, having to track down where some other developer that used to work at the company before you, having to track down where they got this open source project off of some website or forum, and figuring out like if they're like how to pull in the updates and get it compiled on all of the systems you need to compile on. Woo! That is a tough job. Those doing C++ today don't know how good they have it. Okay, so I just wanted to verify that that's still configured and built. For debug, I wanted to do the same for release. Release is not showing up, so I gotta fix... I might just need to do a reload. And this is an artifact of VS Code and not like CMake presets. But the way VS Code handles presets, it has to manually parse these files. It doesn't actually use them as presets. And that was a fun bug to track down one day. Okay, there it is, release. So we configure release. We build. All right, so everything's still build. We're still good. So we're slowly modularizing just our two Windows configurations. We're going to turn these into components so that I can then compose this for other platforms, Linux, Mac, etc. Okay, so the next thing I want to do, because I'm not going to remember to do this off the top of my head. I am looking at notes, so forgive me. I think I want to pull the Ninja generator out. Ninja, yeah. Okay. So we have config release, config. So now I want to do name. We're going to call this config ninja. And there's a method to my madness for the naming conventions. It's just to organize. I'm going to organize these as files eventually. And I think that's all I do there. Pretty straightforward. Because again, if I do want to swap out my generator, if I do want to use, say, the new Visual Studio generator, or the new Visual Studio 2026, I can specify a Visual Studio generator instead of Ninja, and still be able to use these other CMake presets to compose my project. Config Ninja, and then I need to replace. So I no longer, I want to specify it here, so this becomes config Ninja. Then I can remove this. This becomes config Ninja. I can remove this. Okay, all of that appears to have regenerated, so let's make sure. I'll switch back to debug. It configured. Looks like it's still configuring with Ninja. That's good. Hit compile. Still compiles. We'll do the same for release. All right, cool. So what's next? What do we have left? We essentially have these compiler flags and the compiler. So I typically, everyone's going to have their own way of organizing. I don't know if too many people are doing all this preset stuff yet. But what I like to do is I like to stick the compiler flags with the compiler. So I am going to define a compiler MSVC hidden. I probably should just call that like CL or something, but I've already like landed on this naming convention a while ago. If I was being a little more accurate, I'll go ahead and put the compiler flags here. And this is like for a brand new C++ project on Windows, at least. This is like the bare minimum of compiler flags I'm almost always using. If you're not used to compiling with the permissive removed, you should start doing it. Especially if C++ developers working for me, we do not play around. Let's see. We have compiler MSVC. So now what I can do is compiler MSVC. And I think I can get rid of the rest of this. So now I have a fully composed preset. And then for any other platforms, I can reuse some of this stuff. All right, let's make sure this compiles, release, build. We're good. Debug, build, we're good. Cool. All right. So now that I have composed this, there's nothing left. There's no like configuration meat left in these presets. I want to move these to a different file location so that this single preset doesn't get cluttered and becomes harder and harder to maintain as I continue to add more platforms, more compilers, more tool chains, etc. So I am going to create a CMake folder. Go figure. In fact, if you look at any big projects that use CMake, they almost always have a CMake folder. Older projects, you'll just find like find modules in here, but we don't really do that anymore. We do VC package and package managers. All right, so in here, I'm going to create a config folder. I'm going to create a compiler folder. Now, I need a place to put my Windows definitions, so I'm going to create a platform folder. Okay. So inside config, we're going to need a file for each of our config types. So this will be binary dir.json. Oh, don't open the file. I just want to create it. Debug.json. Release.json. Ninja.json. Okay. And then we're just going to cut these out. So config binary goes into config binary folder. Except we still have to specify the fact that they sit within a configure preset, because the way CMake presets work is it overrides what it finds. So we actually need this piece to go with it. I don't even know what flags, if any, I'm running when compiling, but I don't do C++. Yeah, that's fair, right? I would say if you're just tinkering with C++, you were asking about premake, so I don't know what premake does, but CMake will, automatically set a couple of compiler flags for you. It'll make sure that if you're configuring for debug, that you get debug flags. If you're configuring for release, you'll get release flags, that kind of thing. It's only when, you're starting to get into more complex builds that you're probably going to want to stress about compiler flags. C makes one of the, or C++ is one of those languages where it's like, if you don't need it, or you don't know that you want to pull it in, it's not going to do it for you. Whereas I think, I could be wrong, but I think more modern languages that are coming out, they give you more reasonable defaults. Now, all that being said, I think with C++ 26, that's going to change. I'm pretty sure I was reading that some stuff is going to be turned on by default now, at least from like a security perspective for C++. It doesn't necessarily like fix all the issues, but it turns some stuff on. I haven't really played with C++ 26 yet, so I can't really speak with expertise on it. Config binary dir. Okay, so we got that. Now I need to actually, it'll be easier if I just copy this, paste it here, come in here, grab the debug, and paste it like this. There we go. Okay, so then I can copy debug, paste in release, and just rename it. Then I can just get rid of release. Ninja, I copy, paste. Okay, so now I can get rid of Ninja. And then I need to get the compilers. This is msvc.json. So we'll copy that. So now I don't need it in here anymore. So we're already starting to clean up this file, but now this file is busted. So we need to include and that should pull back in our MSVC compiler, our release debug config, and our Ninja config. And we will verify everything's still not broken. Ooh, well, don't forget, sometimes you might need VS Code to reload. Hopefully that's the issue. Ooh, that's not the issue. Okay, so what did I miss? Ninja.json cannot be found. Right. Ooh, actually, I think, I could be wrong, but I think the CMake presets are, like, relative pathing based. Let's do a reload window again. What am I doing wrong? Could not find configure preset config binary dir. Config binary dir. Located in config. Oh, it's because I didn't include it. Right. ABCD binary dir. Alphabetize. Keep everything sorted if at all possible. Just makes it a little easier to parse through as a human. All right. I think we're good now. There we go. So we have MSVC debug is back. It's generating. It compiles. Do the same for release, just making sure. All right, cool. So we have essentially got Hello World up and running for Windows using composable configuration. Not composable. That's not a word. So now I want to move this into its own platform, and then we're going to do the exact same thing again, but for Linux. So we need a platform folder. Did I already make one? I already made one. Come on, guys. We'll call this windows.json. And we will copy the entire content of this into our platform. We will give this a... no, we don't need to give this a name. What we do here, though, is we include our CMake, our .CMake Windows platform. Did I screw some? Oh, yep. Don't forget, we are now dealing with relative pathing. So now this becomes, since we are inside a CMake folder. That's not right. You got to go back one. You got to go up a level. Don't forget to go up a level. I'm pretty much exclusively writing code on Linux and using GCC, and I'm naively thinking that's already better than if it was on Windows and MSVC. Let me do weird stuff. Yeah, it's tough. It really is. Especially if you're not, like, it's all about being used to it too, right? It's what you're experienced with. I started out with C++ on Windows using Visual Studio, and I was a Visual Studio developer for the longest time. Now, I still did Linux development with, like, Makefiles, and, I'm in a position now where I run teams. I have developers who work for me. And from a business perspective, I can't have every developer doing it their own way. Having a separate repo for Linux, a separate repo for Windows, having separate configuration for Red Hat Linux and a separate configuration for Ubuntu or Raspberry and you know, that kind of thing. And so if I can make a project putting in, I won't deny there is, as you're witnessing, there's a little bit of, you got to know what you're doing for one, and I've done this a million times, but two, there is a decent amount of effort to get to this point, right? So everything I am laying out on stream right now, and what I'm hoping to turn into a video, if I can learn how to edit a good video and not just make it terrible, is a how-to on how to make a consistent C++ cross-platform project, right? If you can configure your project and build it the exact same way on any platform, test it the exact same way on any platform, that saves so many man hours of development and maintenance when you have 4 developers working on this, 10 developers. I can't even imagine beyond that how much more difficult that becomes, right? And everyone has their own way of doing what I'm doing. What I'm doing is just what I believe is the right way to do it, right? Every senior engineer has their way of doing it, because every senior engineer has experienced the pain of getting to where they are today, right? So this is my solution to that pain. All right. All right, so now my CMake preset is, hey, you want to support Windows? Now pull in Windows. And the cool thing is, with the big thing with CMake presets is it doesn't override CMake configuration options that someone else wanting to compile your project for their code with their compiler flags. They can still do that. CMake presets is essentially like the recommended configuration of a project. All right, so once we know this still actually, I do need to make sure this still compiles. But this will be a good commit and push point. Perfect. Okay. So I want to commit these changes. This is the first commit of the repo. Technically the second, because I think GitHub automatically commits a README. support Windows compilation via CMake presets. All right, here comes the fun part, Linux. How do I compile this project on Linux while I'm sitting here on a Windows machine using Windows compilers? And make sure that the way I compile for Linux is what you would expect to see on a Linux system. I will show you. There is a thing called dev containers in this world that VS Code supports. And it is probably one of the coolest things I've ever experienced as a developer who does a lot of cross-platform development. What are development containers? A development container, or dev container for short, allows you to use a container as a full-featured development environment. It can be used to run an application to separate tools, libraries, or runtimes needed for working with a code base and to aid in continuous integration and testing. Dev containers can be run locally or remotely in a private or public cloud and a variety of supporting tools and editors. Right. So why dev containers? Couple of reasons. When I am working on a C++ project, even a toy project, I am still going to use software pipelines, CI/CD pipelines, GitLab, CI/CD, GitHub Actions, that kind of thing. And in these pipelines, they have their own unique configuration to get environments stood up and to get your code compiling. Sometimes it is decoupled from the actual project you're working on. I have been at companies or I have seen teams do it this way, and I hate it. It is the worst way to do software engineering, in my opinion. Well, it works on my machine, right? Have you ever heard that as a professional? It works on my computer. Why isn't it working on yours? It works in the pipeline. Why isn't it working on your computer? Because it's not the same. These teams stand up pipelines that test code differently than how the code runs on your computer. So what I do now is I use dev containers. Dev containers allows me to take a Docker file that is specifically configured to compile, build, test, etc. for your project. I then take that same exact Docker file, and that's the Docker file we use for testing in the pipeline. So now your software pipelines and your local development environment are using the exact same code, the exact same configuration. Something goes wrong in a pipeline, and gosh, I can't tell you how many times I've experienced issues with like needing to get a product out the door and a software pipeline has failed, and I am rushing to like remote into it to fix the issue, to debug the issue. Like, dang it, right? VPN issues get in the way. Slow network speeds. I got to download these artifacts so that I can test it locally and try and reproduce what's happening in the pipeline. Man, if your project is using the exact same configuration as your software pipeline, then you should be able to easily test it locally, figure out what the issue is, push up the change, and feel fairly confident it's going to work, right? Now, I understand there's going to be edge cases to anything and everything I talk about here, but 90% of the problems that I have experienced with software pipeline disconnects from project repos, I have solved with this using the exact same Docker file. So we're going to use dev containers to stand up a Linux environment. So how do we do that? So we're going to create a folder called dev containers. This is it's either a VS Code thing or a general dev containers thing, except it needs to be singular. And inside dev containers, we will define a Docker file, which will contain all the configuration we need for our project. and we will create a dev container.json file. So I want to start with the Docker file. So this Docker file, I don't know if everyone watching is familiar with Docker files. So Docker with a different name. It's using Docker. Under the hood, it's using Docker, but it's automatically handling launching the Docker container with configuration options to inject your repo into the Docker container so that you can compile your code, and then any artifacts that you want to keep will get pushed, or not pushed, but they will be compiled outside of the container. That way you can essentially, like from a GUI perspective, I can open and close VS Code whenever I want. Like open it up, boom, I'm in a container. Compile, write some code, run tests, etc. Produce my output, close VS Code, navigate to my local folder, and all my binaries are there. All my artifacts are there. So I can run my program, etc. outside of the container. So just like Docker, it gives you a way to have a clean development environment. And I'm going to be using Ubuntu just because that's what I'm most familiar with. No other reason than that. But you know, it's Docker, so you can pretty much use whatever you want. So I am going to say from Ubuntu 25.10. Why 25.10? Because I want the latest compilers that I can get, because I actually have another project where I've already done all of this. I'm just going through the motions here to provide an example, but I do have all of this already stood up in a more complicated manner. And this project is just my Tinker project. I'm using C++ 23. Whenever enough compilers support 26, I'll switch to that. So, you know, I'm using C++ modules, these .ixx files, etc. Like all my CMake presets are here. They're inside this folder. So everything I've already done all of this. All of this already works, but I'm just going through the motions here because I've had some people question like, hey, how did you get to this point, right? And I realized like I started streaming with all of this already done. So I wanted to show people how to actually do this and make a video that could be like rewatched later. Especially for my own guys. Okay, so Dockerfile. Some of this stuff is just standard Docker stuff. We're not going to be interacting with the container development process, so I set the front end to non-interactive. Now, the important thing here, since we're just doing Hello World, the only thing I really need right now to get installed are compilers. So I am going to make sure I do that. And I'm going to copy and paste. I don't know if Ubuntu 25 lets you install GCC 15 by default, but if you want to install 15, you can explicitly say install 15. And then make sure, at least with Ubuntu, make sure you set it up to have your GCC and G++ executables point to the 15 version. I also want to make sure I get Clang installed, because we will be making use of Clang. I haven't not done Linux development with Clang in probably 10 years because of Clang Tidy and the Clang tools that provide. I don't let my developers do any kind of development without it at this point. And I'm so used to it by now that I kind of need it whenever I do development. But we are going to install Clang 22. Why 22? Because again, I want to support C++ modules, and I have found that 22 has the best support so far. I think 23 exists as well. I just haven't updated to it. So this installs Clang 22, Clang format. Clang format's a godsend. You always want to keep your code formatted, but you don't want to do it your way. You want to do it a consistent way. Clang Tidy, Clang D for the language server, LLD for the linker. And then again, Ubuntu update alternatives to make sure all of our Clang tools are available in the path. Is there anything else I need right now? I think this is a good starting point. We've got so much more to do when it comes to getting this running on Android and WebAssembly, but just to get Hello World compiled, I think this is all we need. Let me check one more time. Yes. I'm not exactly sure if I would say it's best idea to use non-LTS. Yeah, like I said, it's not. I'm not doing anything like that's going to run in production right now. Anything I'm doing here is for fun and learning, right? To get access to the latest tools, to because I like to get ahead of the game. So professionally, I'm still using like C++ 17, C++. I'm starting to use a little bit of C++ 20, but if I do that, then I never learn about the newer language features. I never like grow as a software engineer from just a technical or mechanical aspect, learning the newer language features, trying to keep up with the crowd. So I'm not too worried about like making. I'm not too worried about stability or anything like that. I'm always living on the edge when it comes to technology for personal projects. All right, so we've defined a Docker file to install GCC and Clang compilers. Now I want to set up my dev container file to actually launch my dev environment inside this Docker file. So we give it a name, Python. Why would it autocomplete to Python? That's just nonsense. What did I call this project? CMake Platforms. We tell the dev container it needs to build the Docker file. So we do that by saying Docker file is located inside the location of where this file is. Docker file, that looks good. I think that's all I really need right now. So I'm not going to do anything else. And it's, I would assume, hard to justify newer language version when it's not even fully supported after. Right. Yeah. It's especially like for businesses, it's really hard. Like I have had to have conversations with stakeholders, if you will, on like how important it is to at least try and stay no more than 3 years behind the language standards if you can. Like obviously the compilers don't stay in sync with each other necessarily, so some language features aren't going to be available, but as soon as you can start using newer language features, it's just it's beneficial for, the standard reasons, like, right, bug fixes, security improvements, um better ways to write code, more performant ways to write code, that kind of stuff. So like I always try to be no more than 3 years behind. Currently I am, like you said, 6 years behind. um but I'm working for, I'm contracted. It's weird, I'm with a company contracted to another company, so I don't have as much say doing work for another company. But when it's within my own company, we'll almost certainly be at least on C++ 23. um it just depends on what language features we want that, the standard three compilers, Visual Studio, Clang, and GCC give us. Okay, so I think that's all I need. So once we have this defined, at least in VS Code, now this isn't a VS Code thing. Like dev containers, I'm almost certain works for like NeoVim, Zed, any IDE or editor that gives you access to extensions. I'm almost certain you can use dev container with. Now, part of the reason this will work for me is I am using WSL, Windows Subsystem for Linux, under the hood, which is a lightweight version 2, which is a lightweight Linux VM. So it will give me access to graphics, which will be important later in this stream. But I'm going to come in here and I'm going to reopen in container. Ooh, that's awkward. Oh, I spelled it wrong. Docker file Dockfile. Dockfile. Spelled it wrong. All right, let's try it again. Boom. All right. So just like Docker, it's got to build the container, or it's got to build the image. So we're going to sit here and watch it build the image out of Ubuntu 25, installing the compilers. Do you think reflection will be better way to write code? Ooh. I don't know about better, but I am excited. I'm excited to try it out. It looks kind of complicated. It looks like trying to relearn template metaprogramming. I think low-level libraries that we typically consume with our own projects are going to become significantly better. I think there's a serialization library out there called Glaze that is already integrated reflection into its serialization, and it's just like miles ahead of anything. And I just watched I don't think it was CppCon, but I watched a C++ video last week, I think, where someone wrote a JSON parser using C++ reflections, and it is now like miles ahead performance-wise of parsing like gigabytes per second of JSON than any other library. It is like, don't quote me on this, please, because I don't remember I don't remember exactly what the performance metrics were, but it looked like it was anywhere from like 2 to 6 times faster than the fastest C and Rust implementation. Like C++ Reflections has unlocked ways to write more performant code than we have ever had before. So I am curious to see what comes of that. I don't think the average Joe Schmo will have to necessarily worry about writing a bunch of reflection code, but I think a lot of the libraries that we use behind the scenes are probably going to slowly upgrade to using reflections, which means just everyone gets a benefit from it. Ooh, hey, look, my daily what is this? A ViewBot advertisement. Begone, outlandish crack Jew. Hey, Taxis, how's it going? Oh God. All right, you've come in at an awkward time. I've got errors on my screen. I've got a ViewBotter trying to advertise for me to purchase bots. All right, I need to compartmentalize one step at a time. I need to fix this error. Actually, I need to ban that. How do I do that? Do I have to do that in Twitch? I can follow them. I can gift them turbo, but I don't see a... Oh, here we go. Ban! Got him. Problem solved. All right. So what went wrong here? Probably a syntax error. Unable to locate package Clang 22. Run apt-get update. This is the problem with copying and pasting sometimes. I may have missed something. Is your main job software too, other than streams? Yes, Taxes. I'm a full-time C++ software engineer, technically a chief engineer. So I still write C++ code. I also run some teams. You know, I make sure everyone's remains productive by stuff like this. I'm not a full-time streamer. Today's Friday, so I got off a little early, so I figured I would start a little early because I wanted to make a video. I'm gonna try and make a YouTube video. We'll see how that goes. I am not a video editor, so no promises. You're gonna see Microsoft Word art across the screen. That's my video editing. Yeah, no, I'm just I'm a full-time C++ engineer. I'm just doing streaming for kind of for fun. I'm sitting here tinkering on these software projects, and I figured even if no one shows up, I can at least do this on stream in case any friends wanted to come by and learn a little bit of C++ and how I do things, that kind of thing. But yeah, I'm like, you caught me on a day where I got off work a little early, so I wanted to create a video on how I set up a cross-platform C++ environment where any developer can like clone the repo on any operating system and build the project for that operating system. No, I appreciate it, Taxes. Streaming's here just for fun. I'm not trying to. I am what do you call it? I'm a realist, right? I'm practical. We've all kind of hit the or missed the mark on getting rich and famous streaming, and I also don't play a bunch of games and yell at kids, so I'm not gonna attract a bunch of people. So it's only if anyone who pops in who understands anything about programming, I'm here to chat. So you writing a script or a CI? So I am currently writing a Docker image file that I will use for both CI/CD and local development. And I am failing miserably at it because I got an error saying that it failed to run apt-get update. I don't know why. Apt-get update. I gotta check something here. What did I screw up? Wonder if I didn't install. Ooh, did I not install curl? Oh, yeah, okay. Yep, that's a whoops. There's other tools I need to install. So, in order to get Clang to do what I needed to do, I need to download Clang and run the LLVM script. And then I also need to get some common tools like curl to make, like, I'm going to need CMake in my dev container so that I can, do CMake presets. I'm going to need Ninja, just like I installed on Windows. I need Git so I can clone curl so I can grab some stuff. You need the certificate authority certificates so that all of these tools reaching out to websites can talk to the websites. So I need a lot of this stuff. Some of this stuff I don't necessarily need, but I'm going to go ahead and keep there for later. So like USB utils, that's obviously USB. That's going to allow me to bridge my operating system into the WSL environment, into the dev container, so that I can plug my phone into my computer and do an ADB install of this application onto Android. So some of the stuff I'm just going to have here. But we will give this another shot, and we will reopen in container and let that try and build. We can watch it do its thing. Nothing more fun than watching paint dry, am I right? Oop. Who's texting me? All right. But yeah, so this is basically Docker inside WSL, building my Docker file. Once this gets built, Docker in WSL is going to run an image or run it as a container, and then dev containers is going to inject my project into the container and then give me access to all these tools just like you would if you were to run Docker yourself. Oh my gosh, Taxus. That is a long conversation. So, and I'm not an expert at Docker to speak confidently with it, but I can tell you what I know. and you'll have to look stuff up to verify if I told you a lie. How do I explain this? Linux and Windows works that's too much. That's too low level. Okay, so think of Docker like kind of like a virtual machine. It's this self-contained environment where anything that goes in, like anything you do inside the container, this is Linux, by the way. If I create a file inside a Docker container, so I'm in Linux, I launch a Docker container. I might be able to show you, honestly. Do you guys see this terminal? So I'm on Windows, but this is my WSL environment. So I'm I'm essentially in Linux, right? So if I take a look, LSB release -a, you'll see I am on Ubuntu 24.04 LTS. Docker is just a command, so I can, I can check its version. But one thing I can do with Docker, is it images? I don't remember how to do this. Docker images ls. Docker image ls. Okay, there we go. Docker allows you to take like snapshots of Linux state and build on top of it so that you can run it in a self-contained environment, use its tools, create files, build code, and then leave the environment. When you leave that environment, your original instance of Linux is untouched, mostly, unless you tell it to. And so the purpose of Docker is so that any specific tools I need for my personal project that maybe I don't want polluting my Linux environment, messing with environment variables, accidentally overriding or creating symbolic links that mess up links to other tools. If I don't want any of that to happen while I'm working on my project, I do it inside of a container to make those changes, to make those symbolic links, to create new files, so that when I leave the container, my everyday use of my Linux is working the same. It doesn't get messed up, right? And I think I don't think it's Docker per se, but I think a lot of modern Linux distros allow you to install applications this way. And again, I don't think it's Docker under the hood, but like you've probably, if you use Linux, you've probably heard of things like Flatpak, I think it's called. Ubuntu has Snap. I think there's another one, right? But it's the idea of these immutable Linux environments, immutable Linux distros, where you're not really modifying any like system files or anything like that. Everything you do happens in these containers. It's like similar. I just don't know if it's the same thing. But that's what I am doing here. Since I am on Windows right now, I don't want to, like when I'm compiling code, I don't want to screw up my Linux environment because I need it for other stuff. So what I do is I create this Docker file, I create this dev container, right? This Docker file inside my project repo. I create this Docker file that says, hey, use Ubuntu. Is that text small for you guys? Can you see that? No, you can see that. I could make it a little bigger. How do I make it? Control-Shift+. There we go. That's a little bigger. Oops. But I'm creating this Docker file that's essentially a script that tells Docker how to build these image layers off of Linux snapshots. And so it's like, hey, start with Ubuntu 25. Now, there's a website out there called Docker Hub, just like GitHub, where all kinds of people have built their own containers. Like you can even go out to Docker Hub, because I've done this before, and grab like a game server. I play 7 Days to Die with my friends sometimes. And so I just go grab a server container and I can just do Docker run container and boom, I have a 7 Days to Die server. Now, obviously you have to pass in some configuration parameters, but boom, right? Same idea. So this goes out to Docker Hub and grabs the Ubuntu 25.10 image, And then I'm just running Ubuntu commands. And each of these commands is a separate layer that gets built on top. So then when I run the dev container, which I did in VS Code, so I am actively in a dev container now. Like I can open a terminal and I can do inside here lsb release, which might not work because I didn't install it. Yeah, I didn't install it. So I could apt update. Where do you get the lsb release tool? So you're telling it is something like a virtual machine container that has its operating system? Yeah, it doesn't have its own operating system. It borrows from the kernel, so it uses the same kernel that that your Linux is running on, right? So it still uses all of that. It's honestly, at the end of the day, it's almost like a folder that you create on your Linux box where nothing outside that folder is allowed to touch it or modify it. It's almost like creating a folder, giving it a unique set of permissions, and no one outside of it is ever allowed to touch it. It's more like that, I think, than a virtual machine. And so then it just, inside that folder, it replicates your Linux files, right? Your Linux system files. Things like that. Like I said, I am not I wouldn't say I'm an expert on Docker. I can configure it, I can run it, I have used it, but I have not done anything like low level with it. So I'm, I can only tell you what I myself have watched in YouTube videos, assuming those videos were correct. Apt install lsb release. Is it that easy? Man, what's the package for Oh, I did underscore. It's a hyphen. All right. So you guys saw that I am in a Ubuntu 24.04 Windows subsystem for Linux. But inside my container, which I built using 2510, that is what I am using. That's Taxus. That's Docker image is the last snapshot configuration to a Docker container before runtime. That's probably a little bit better way of thinking of it than like a virtual machine, because it's almost like when this from Ubuntu command runs, it has to go out to the internet and grab the Ubuntu 25 image. Well, what is in that image? It's all the files and folders that make up a very, very basic Ubuntu 25, right? So then the next image that gets built on top of it, the next snapshot, is this run command that will run apt-get, which comes with Ubuntu 2025, in order to install these, right? And so this Ubuntu 25 is going to have like your repository list. So it will be able to go out to the internet and find the packages it needs to install. And the benefit of these layers is they can be updated or changed independent of the other layers. So the next time you rebuild, you don't necessarily have to rebuild the whole image. Now, that being said, I still think it might be like bottom to top. So like if you make a change here, then anything in here that depends on that change all have to get rebuilt. Whereas if I just made a change here, only this layer has to get rebuilt. And you can see that, right? If I go to my WSL environment that is hosting, the Docker images, I should be able to look at the layers. I just don't know what the command is off the top of my head. Let's find out. Docker list image layers? Question mark? There's a way to do it, I think. Docker history image name. So I have to do Docker images ls. Nope, I did this. What was it again? Image ls. So then I find the image that I just built. So you can kind of see that my dev container environment is building these hashed images. Like VSC is Visual Studio Code. CMake Platforms is my project. And you'll see that this image is 2 gigs, whereas the Ubuntu 25 image is 137 megabytes. So apparently, Ubuntu 25 it only takes up about 137 megabytes. Disk usage. So I don't know what that means exactly, other than that's probably how much space on the disk is being consumed. But let's copy this image. And then what is the command? Docker history. So you can kind of see all the different layers that make up this image, right? So the most recent one being the apt-get update, apt-get install, which is right here, right? The latest image. So and so installing Clang took 368 megabytes. Downloading Clang took 36 kilobytes. So on and so forth, right? So all of these layers combine to, when it actually runs, essentially kind of unzips or unextracts into that folder I was telling you, and you're running Linux. Uh, Careful with your statement there. Docker containers have nothing to do with Windows. So on Linux, I run Docker containers so that I don't modify Linux. My Docker container is also Linux. Windows supports Docker containers, but I am not doing that right now. What I am doing is using, because I am on Windows, and because I have Windows Subsystem for Linux, I am using the Docker service that is in my WSL to run a Docker container with my project and all of my project's dependencies and compilers, so that I can take that same exact Docker file, put it up in GitHub Actions, configure GitHub Actions to use the exact same development environment. That way, I have a pipeline that compiles everything from scratch to finish with the exact same tool chains that a developer would have locally on their machine. Yes, correct. Correct. So I don't want to install tools in my local Linux. So I do it in a container. That way, when the container shuts down, my local Linux is still, clean. All right. So now that I'm in this container, I need to configure CMake. I got a lot of changed files. What's going on here? Oh, we're not ignoring the build folder. Ooh, did I accidentally commit my build folder? That's awkward. Did anyone catch that? Uh-oh. We'll cut that out. We'll edit that in post. No one saw that. I'm a professional. The only downside that you guys are going to observe with doing a Docker container in a WSL environment on Windows is performance. WSL writing to a Windows directory is slow as hell. And so sometimes operations take a sec. Like this. I think this is still processed. Oh my god, look at all those files. I do not want to commit those. Now, why is that not? Do you have an idea what is the relationship for all these stuffs with Kubernetes? Oh boy. So Kubernetes is a container orchestrator. So now, oh, you're making me have a massive talk on a bunch of not related stuff, but Kubernetes, like if you have these Docker containers, right, that can have self-contained environments of Linux files and environment variables, well, once you have that, you now have a way to launch a service without needing to mess with anything, and it becomes really, really easy to launch a service. All the configuration files that go into making a service run, different port configurations, whether you're running on like TCP, UDP, so on and so forth. You can build these services, which is really just an executable inside a container or multiple executables that run. And then Docker lets you expose ports through the Docker layer into your Linux environment. So now you have all these services you can run. Well, sometimes services fail. Sometimes they might crash. Maybe you have a large computer with many cores and you don't need to consume all of them for a service. So you need a way to orchestrate these services. You need a way to launch these services to maybe only use like one core or half a core. Maybe your service only uses a few megabytes, so you don't want that service to have access to your entire collection of RAM, right? Maybe your service crashes, and when it crashes, instead of staying dead, you want it to automatically relaunch. Kubernetes. So Kubernetes orchestrates all of that. You configure Kubernetes, and the cool thing is with Kubernetes is it's designed to be scalable. So what does that mean? Maybe you eventually run out of resources on your computer. Maybe you're running like 5 different Docker services on a Raspberry Pi and you're out of cores. All right. Ooh, can you guys see it? Maybe you have a rack of Raspberry Pis that you run Kubernetes on, so that anytime you run out of resources on one of those Pis, Kubernetes can say, hey, I have 3 other computers tied up as nodes or registered as nodes in my Kubernetes environment. How about you launch the Docker service over on that one instead? So that's, in a nutshell, Kubernetes. I don't necessarily want to go too much more into that, because one, that's an entire 8-hour plus talk, and two, I don't know enough to talk about Kubernetes for 8 hours. Yep. Yep. Kind of like a load balancer. Yep. As I understand it. You guys have made me talk so much more than I expected this stream, and I can already feel my voice starting to falter. I gotta figure out why my gitignore isn't working. Am I supposed to do this? Well, let me check my other repo here. No, I should be able to just do a build slash. What the heck's going on? I hate programming. I don't know about you guys. Programming's dumb. Sometimes stuff should work, and it doesn't. And that is dumb. I don't know how you guys feel about it. I do want to make sure I add a get attributes file so that my line endings don't get dorked up between Windows and Linux. Okay, it was just took a sec. It really had to think about it, I guess. Jesus. Oh, I'm happy to. Oh, I appreciate that, Taxes. I really do. You had me talking more about stuff I haven't had to talk about in a while. So it was a good test of my knowledge, if you will. All right, so. Oh, that would have been a good idea. It looks like it worked. It looks like we're good now. All right. So all of that, I should now have G++ installed as a compiler. I do. I should have Clang++ installed as a compiler. I do. So let's see if we can get Hello World compiling. I do need to make sure my CMake tools are installed in my container. So now one thing that's kind of nice with VS Code, I assume this is a VS Code thing. Any extensions you install for like your local machine, if you're going to work in a dev container, you can tell the extension to add to a dev container. That way, you make sure like when you launch your dev container, you get the same tools. So with those same tools, I should be able to configure Windows Linux. Well, see, here's the problem. I'm in a Linux environment, so if I try to configure a Windows build, it's probably going to fail, right? CMake error. It can't, it's a different directory. It's going to have different compilers. Windows is set up to use MSVC. So everything I did to get this project compiling with Windows, I have to do the same thing for Linux. Yeah, no, so AI is a whole other topic, right? I'm not using AI for this right now because I do want to make sure I have like step-by-step guidance. Because again, like I said, I'm gonna try and turn this into a YouTube video. We'll see. I'm not a very good video editor. I've only been doing this for like 2 weeks, but I'm gonna try. And so if I used AI to auto-generate some of this, which it can, it's gonna miss. It's gonna miss like the steps all the way through, right? Because it's just gonna dump it all on screen, and it's not gonna. I'm not gonna have any like video there to be like, hey, this is why I did this. This is why I did this. Oh, bloop, it just appears. No, professionally, I am using AI. It's kind of you kind of have to, for better or worse. I'll say I have benefited from it immensely from the perspective of debugging, especially debugging code bases that like you're using as a dependency, but you're not maintaining yourself. So being able to have AI kind of like walk through it and pinpoint why you're doing something wrong, it saves so much time. Code generation still, it's getting better, but I have a way I like to write code, and so I kind of have to really hold its hand in order to generate the code I want it to, because I still want the code to look like I wrote it, right? Otherwise, it becomes a lot harder for me to maintain. Okay. Anyway, I keep getting off topic. Okay, so we're going to support GCC, and we are also going to support Clang. You got it. If we're on Linux, we're compiling for both, always. I'm going to grab my pre-configured project here to put all this in, because I don't remember all the compiler flags I use. Okay. We can honestly just copy and paste from here and then change the values. Oops. So this is going to be compiler GCC, except we're not, oh, there's autocomplete for you. Except we're not going to define our flag there, I don't think. I definitely want pedantic. I don't know if you guys have done C++ with like all the pedantic stuff turned on, but it's a fun time if you're not used to it, or if you apply it to a code base that hasn't been using it. Ooh boy. Another thing I want to make sure we do that is a Linux thing. Actually, I think Windows supports this now. But I want to make sure we export our compile commands, which is a JSON file that basically prints out all of the compile commands for your project. For one, it makes it super easy to debug any issues you have. Two, tools like ClangD need it. In fact, I want to make sure, because I don't remember if Windows supports it or not. I think it does now. It used to not. I'm going to go ahead and put that there. So we have GCC, pedantic. Let's copy this. Oh, whoops. I put that in Clang. That's awkward. So we'll put that in GCC, and then Clang we will rename Clang. I think Clang uses the same basic flags that I'm using for both. Ooh, no unused line arguments. I don't think I need that right now. Have a great day. Thank you for everything. I will turn on notification. I really appreciate it, Taxis. Have a 2 a.m. Have a good night. Thanks for stopping by. I really mean it. Okay, so we've defined our Clang and GCC compiler presets. So just like with Windows, I'm going to make these presets composable so that I can mix and match. It'll make it a lot easier to maintain. Yeah, generation's tough. It's tougher when you don't know what you're generating. At least personally, if I establish my architecture, I've laid down all the design patterns I want to use in my project, then it's not a big deal for me to generate code because at that point it's kind of just handling boilerplate for me. All right, so that's Clang, GCC. I don't think I need to add any new configs. It might be that easy. I think I just need to define the compilers. Yeah. And that's why we make this composable. So now I'm going to create a Linux platform file. And we will just copy and paste so that we can include all this. Except we're not going to include MSVC. We're going to include GCC. And we will include Clang. And then I guess the autocomplete's going to replace all this for me, which I'm okay with. See, like stuff like this, I think that's where AI shines a lot. Just like saving me the amount of typing I know I was going to have to write anyway. All right. So this gives us GCC debug, GCC release, but we also want Clang. So we will copy and paste this. We'll call this Clang. No. And then we also want to define our tests. There we go. Subbed also here. See it. Oh, wow. Hey, thinking. Thank you. I really appreciate it. That means a lot. It's better when it also writes tests at the same time. That way it has feedback. Yes. Yeah, I agree with the tests too. Obviously, you know, with anything, you still need to have a hand on it, but a lot of the simpler tests where maybe you're just like making sure your API works, I will say AI saves a lot of time. I could just like AI goes brr, right, with testing. You just have to be careful because you want to make sure the test is actually like writing tests that make sense. But man, who knows? I just who knows how fast AI is going to evolve. And who knows? So I'm trying to stay up with it myself, at least professionally. All right, so I've defined the Linux platform. So now I should just be able to include the Linux platform. Oop, L comes before W. Come on, guys. And if that works, we're about to see something happen first try. So just like on Windows, I would come in here and I can select which compiler I want to use. So let's do GCC debug. Come on. Don't embarrass me. First try. Come on. I'm going to compile. It compiled. Compiled on Linux using GCC debug. So then I can do /build x64 Linux GCC debug app hello world, and we have hello world. Look at that. So the amount of time it took for me to get the Windows presets configured and composable versus how much time it actually took me to get it up and running with Linux, that's why we make it composable. All right, so now I want to compile this for Clang. How about Clang release? It generated, compiled. It compiled. So then I can see if I can run it. Build x64 Linux Clang release app hello world random. Look at that. All right, so I've got code compiling on Windows and Linux without having to change my operating system. All right. So I want to, I think this is a good spot to commit changes. Hello, let's see. Hello world successfully compiling with Clang and GCC. What in the world is this music? That's funny. Okay. This is a good bathroom break for me. I will be right back. I need some water. My throat's getting hoarse. All right. Who is ready for round 2? Let's kick it up a notch. Let's do some package management. If I want to draw a triangle, create a window and draw a triangle, how would I do that? Like, where do I even begin? Do I need to go to GitHub and try and find something that lets me draw a triangle? Do I need to write it from scratch? Or can I add a single line of text to a configuration file and it will automatically download, compile, and link my projects into my application so that I can draw a triangle? I feel like the latter would be the cleanest and easiest. Oh, yeah, I got the whatever that's called, the Herman Miller. The let's just say the internet influencing advertisers, they did their job well. It's probably one of the best chairs I've ever used. All right, so I think for this next part, let's switch back to Windows, get it up and running in Windows first, and then we will switch back to Linux again. So the way I switch back to Windows is I just reopen folder locally. Oh, my cat's here. Oh, hi, Trill. You want to say hi? What are you doing? Want to say hi? My cat likes to trill. That's why I named him that. Okay, what are we doing here? That was a different tab. Sound like a pigeon. Okay, so what we're going to do for package management is something called VC package. And the way I go about doing this is, well, regardless, we need to clone VC package from GitHub. In fact, I could probably just pull it up. Wow, this song has a whole story. But anyway, we're going to be using VC package to handle our package management. I like to add it as a submodule and basically like leave it set on a version, because VC package is, well, you can literally see it. It was updated 38 minutes ago, updated 41 minutes ago. VC package is going. It is just nonstop. Keep like, because there's thousands upon thousands of software libraries out there written in C and C++, and VC package has an entire repo of all of it. So we're going to grab it, git submodule it, and kind of stamp it to a specific version. I want to make sure I don't roll on my cat. I think he might be hungry. So I always forget how to do this, so I always have to Google. Add git submodule to project. I'm pretty sure it's just like git submodule add. Yep, I was right. Okay. So we're going to do git submodule add https github Microsoft/VC package. I don't need to specify an optional path, so we will add it. Okay, so now that that's cloned, the other thing I need to make sure I do is change to a different tagged version of VC package. Whatever the latest tag is usually what I grab. Did I say OSG Earth? I haven't seen that in years. Remove vendor image. Wow, surprised that's still being updated. Is that a tag? Aha. So March 18th of this year is the latest tag. So I'm just going to check out this commit. It can be headless. I don't need the branch or anything. I just need the commit hash so that I can commit it. So then VC package is added as a submodule. So add VC package submodule to my project. We'll push it up. Cool. Cool. All right. So how do we even begin to use VC package, or what is VC package? VC package is going to be our package manager. It's going to clone. It's going to download any software dependencies we need to link to our project for us. It's also going to compile it using our compiler toolchains that we have set up in our CMake presets. So to start, we're probably going to need to tell CMake where VC package is, and I am going to look at my pre-configured project already, so I can just kind of copy and paste a little bit. Right. Okay. So we're going to need to define a VC package config file. VC package has its own toolchain we can give to CMake so that CMake knows it exists. Presets. Except we don't want to use hard-coded paths because we want this to work on all platforms. So the expectation is VC package will be relative to our source directory, which is our root directory, which it is because it's a submodule. So that is good to do. Toolchain is a CMake thing. So by telling CMake we have a toolchain file, it's going to load this before it starts running our CMake configuration. I have a syntax error. Okay. All right, so that gives us VC package. I wonder. I wonder if there's a way I can make this. Do I try new stuff now or do I do it after? Maybe I do it after. Do what I know works. I'll do what I know works. Let's not change it up. So one of the things VC package does is it has CMake variables you need to define to specify which platform you are compiling on and which platform you are compiling for. And this is kind of what helps enable us to build our projects across all these different platforms with one repo and like one consistent way of configuring. And so there's the concept of a host and a target. The host is the operating system you're compiling on. So it's not just the operating system, it's the architecture. So Windows, x64 architecture, or x86 64, ARM, or ARM64, right? What else? WebAssembly, Android, Mac, so on and so forth. So we want to define these values for VC package so it knows which platform we are on. Now it has reasonable defaults that it will do automatically, but if we ever want to eventually support cross-platform compilation, we need to get this set up. All right, I need to take 1 sec. My cat is being a twerp. What do you want, dude? Come here. Yep. My cat has food, but he needed me to walk him to it. Ridiculous. Re-freaking-diculous. Okay. So yeah, we need to configure VC package to say, hey, I'm building on Windows 64, and I want to target Windows 64. Because eventually we're going to be, hey, I'm building on Linux 64-bit, but I want to target WebAssembly. I'm building on Linux 64-bit, but I want to target Android. So the way we do that, or the way I have done it, which I'm not horribly happy with, there's got to be a better way. We're eventually going to say, okay, yeah, that's what we're doing. So I'm going to create these host and target folders to put those definitions in. And since we're just doing Windows and Linux at the moment, I just need x64. We're just doing Windows at the moment, so I'll just do Windows. Keep it simple, silly. So here, we specify our host. So this is going to be host x64 Windows, hidden true, because we don't want this showing up in our preset options. We're just going to inherit from it. We're also going to give this a condition. I forgot to do this earlier, and we noticed what happens without it, but like the Windows preset showed up in my Linux environment, and I don't really want that to happen. So we're going to say, hey, given this condition, if the left-hand side is the host system name, and the right-hand side is Windows, so if the host system name is Windows, then we are allowed to use this preset. Cache variables, that's not right. So we're going to do VC package host triplet, and we'll say x64 Windows. So this is a known VC package variable. It is a triplet. It is what defines the tool chains for x64 Windows. If we went into VC package, we would see that it exists right here. So whatever name we put in this host triplet or target triplet, it has to be something inside these triplet files. That's how we tell VC package which one to use. So then I'm going to create a target x64 Windows. So we're building on Windows, and we're going to target Windows. We'll give it a name, target x64 Windows. It is also hidden. I spelled that wrong? I spelled that wrong. All right. So here we're saying VC package is going to build towards Windows 64. Now, normally using VC package, you don't have to do this. But because I'm setting up a more robust dev environment, we're going to do this. Because it gives us a little bit more granular control on how we want to use VC package, which will come in handy later. Scaredy cat. I just saw your forgive me, I've watched some Twitch streams before, but I'm new to the that's just called like an emote, right? Scaredy cat emote. Let's see here. So I've defined the configuration needed for VC package on Windows, but I need to actually add it to the active configuration, which is defined in our platform files. So here is where I would include the autocomplete isn't all that great on Windows for some reason. I want to sort this. All right. So once I've included these, I'm going to add them to my projects here. Now, realistically, I probably want to separate out the VC package stuff so that a user can choose to include VC package or not. But for now, I'll just do this. So we want to include VC package, and we also want to say, hey, this is for building on Windows for Windows. And I also want to sort. Cool. Okay, so VC package comes after Ninja. Host target comes after VC package. All right, the last piece of the puzzle is pulling in a dependency. I hope. That's actually not true. We got a couple more steps because we actually want to write some code. But to use VC package, you're going to have a VC package JSON file. And this JSON file is where you list your dependencies you want to automatically pull in. We're going to give our project a version string. We'll just use today's date, which is 4.10. This will have a port version. I'm not going to go over all of what these mean. We'll let those curious read up on VC package if they care to. Homepage. I guess it's going to be my... Nope, it's not Microsoft. Don't give credit to Microsoft. I'm writing this. Okay. So this dependencies is where we're going to actually list our dependencies. So what do we need to draw a triangle? I think Raylib is probably one of the easier solutions we can use. SFML exists too. Raylib is probably more popular, so more people will know what it is, I'm guessing. No, that's not what I wanted. Yeah, Raylib has 32K stars. I don't think SFML has that many. That's 12K. That's not bad. But Raylib's more popular, so I think more people will understand what Raylib is. So that's what we'll do. So we're going to say Raylib. How do I know I can do that? Well, inside VC package, there's a ports folder. This ports folder lists every single software dependency that VC package supports that you can list inside your VC package.json file to build software. Anything and everything you could possibly want is probably in this list. There's probably only a handful of libraries out there that are not being pulled in yet, and they are being requested to be pulled in inside Microsoft's GitHub issue tracker all the time. All right, I've made it to the letter M. We are still going. These are all the software dependencies you can use to build whatever software you want. Oh, look, if you want Qt, you can use it to grab Qt. We can keep going. Oh, I see some rapid JSON in there. That's a common one. libpng, SDL, QR. Oh, we already passed R. Element OP, QR. So Raylib should be... Look, there's Ray GUI, Raylib, Raylib CPP. Raylib has a CPP? Did I know that? Oh, that's someone else who did that wrapper. All right, anyway, we're going to specify Raylib. So now what do we do? I specify Raylib, but I don't have my my dependency yet. Well, let's go get it. We get it by configuring. And you configure by using your CMake preset. We're doing Windows, so we're going to specify... let's do debug in case we run into issues and we need to debug. And we're off to the races. So, now that we're configuring, we've told CMake that VC package exists. We pointed it to a VC package toolchain file. That toolchain file is going to go in there and read that VC package.json file for the dependencies of VC package that our project needs. It's going to use, like, VC package has an executable that it runs, and it's going to process all of this, and it's going to start downloading and installing. Except maybe it didn't, and I just said all that awkwardly. No toolset architecture specified for CL. I might have to, again, this might be a VS Code thing. I might have to reload the window in order for the toolchain to be specified. Yeah, I'm not seeing, no, it's right here. suspicious. Why did that not build? So what should have happened is we should have saw it grab Raylib. So I screwed something up. What did I do? What did I do wrong? Let me reload just in case. Reload the window. No toolset architecture specified for CL using x64 by default. We might have to fix that too. All right, configure. There we go. Yeah, so it was a VS Code issue. You have to reload before you configure. So now VC package is running. You can see that it's like going out to the internet to download these dependencies. And then it's going to compile those dependencies with your compilers on your system with the flags that you've defined for your project. It's going to build it for debug and release. And we see the last package being built is Raylib. And then once it's done, it gives you the CMake script needed to find Raylib and link against it in your application. So we're going to do that. So I'll copy this. Dragonite? Is this a Pokemon rap? All right. So now our application is linking against Raylib. We're going to configure it again to make sure it actually found it. It found it. So we'll configure it. Sweet. I forgot. I don't want any of this up right now, distracting me. It just gets in the way. Okay. All right. So now what do we do? Well, let's draw a triangle. Let's create hello triangle. So this is no longer hello world. This is hello triangle. So we're going to rename this. We're going to put this in a folder called hello triangle. We need to create a CMake list file that specifies the app folder exists. So, oh, come on. Add subdirectory app. Cool. Okay. And then now we should be able to include Raylib. And be able to do like something simple real quick. Like, what is, I don't even know how to use Raylib in that window, I think. Oh, look at that, autocomplete. While window should close. Cool. Draw text, hello world. All that looks fine. I guess let's see if it compiles. It did not. What do we do wrong? Oh, I might need to configure first. Oh, nope, I see what I did wrong. Hello triangle. Gave it the wrong name. Let's try that again. Build. All right, it built under app hello triangle. So let's run it and see what it looks like. Did we do debug? We did. App hello. And we now have an application window. Look at that. Pretty cool. Except we want this to be a triangle. So can I do like draw triangle maybe? I mean, if you're gonna offer me a ray gray, ray black, black, gray. Ooh, is there a dark green? What does that look like? Ooh, okay. So something else that we don't have in here that we need is formatting. This is hideous. Having a single line of code like this on the second line, I can't read what's happening here. So I'm gonna fix that real quick by adding a Clang tidy file or a Clang format file. I probably should have done this earlier, but that's okay. I'll grab one that I already have. So we have a Clang format file. This formats my C++ the way I like it. Then we need the Clang format extension, I think. Which you already have. Perfect. Okay. So now if I save, there we go. That looks a little cleaner. Okay. I can do this. This is a crazy way to write code. Don't write code like this. Don't, no. Vector 2. Let's see. We're doing an 800 by 600. So what's halfway? 400. 400 by... Oh, there we go. Let's see what that does. We'll compile our project. Try and run it again. Hey, check it out. Christmas. I feel like I'm doing a disservice to anyone who's red-green colorblind, though. Let's do, like, gray. I think gray is fine. Gray. And what else we got? Dark. I feel like blue and purple would be too hard to see. Cyan? Orange? What does gray and orange look like? Hey, there we go. That's almost like Sublime Text. All right. So we have an application window rendering a triangle on Windows, and all I had to do was specify Raylib as a dependency, and I automatically got it. So now let's do it for Linux. Wait, there's a trick here. Actually, let me commit these first. Ooh, he did not like that. Why is it? Oh no, I think I did accidentally commit my build folder. Cause I'm a noob. Gosh darn it. Okay, so I have to untrack it. I think that's like what, git remove? How to remove, how to untrack folder in Git. I think it's like git remove cache. Git remove r cache folder name. Okay. Git remove cached folder name. No one saw that. No one saw that. Okay, so that's going to remove everything in the build folder, which is what I want to happen. Oh my god, I must have committed a bunch. Okay, so what's actually getting committed? Okay, everything in the build folder is getting deleted. That's good. All right, all that looks good. Okay. So I want to working hello triangle on Windows. Sweet. All right. So what's next? I've got it working on Windows. So I guess Linux is next. But because I'm in a WSL environment and I'm running in a container, I need to set up my situation, if you will, to support graphics, which means I'm probably going to have to do some like display forwarding, which I've already done. So I'll be able to add this. I thought I did. Oh no. Did I lose it? What repo am I in? This is awkward. Maybe I don't need it. We'll give it a shot. We'll try it without it first. Okay, so Raylib, we're going over to Linux, and we need to do the exact same thing. So let's go over to Linux and do the exact same thing. We will hop over to our container by reopening it. Manage, let's see, that's fine. Live in that. Okay. So on Linux, we're gonna have to do the same thing we did for VC package, but on the same thing we did for Windows, but on Linux. So host and target, we're gonna need to create a host x64 linux.json. We just kind of copy this. This will be Linux, Linux, Linux. All that looks good. And then here we will create an x64 linux.json. Create Linux. Okay. And VC package we already defined, so we just need to add these to the platform. Okay. So that integrates VC package with our Linux builds. So now, just like on Windows, I should be able to go to my CMake tools extension, hit configure, and we will see it fail miserably. Because I probably need to reload again. All right, let's try again. So we hit configure. There we go. All right, so bootstrapping VC package, so it's downloading the VC package executable. And now it's going to pull in dependencies to build Raylib. Now, I suspect one issue we're going to run into is we don't have any like OpenGL Mesa drivers installed in the container, so it will probably see this fail to compile, and then we're going to have to update our container to support Raylib. And it's going to take a little longer to do in my environment right now because, again, I'm in WSL, but all the files are getting written to a Windows directory. And if you know anything about WSL, if you're working with local Windows files through WSL, it's slower than if you were just working with the files inside the VM. There we go. It's starting to compile. There's STB. Good old STB. But the cool thing is, if this does fail to compile, VC package usually tells us which packages we need to install to make sure we have everything we need. Like right here. We might fail to compile right here. Yep, we failed to build. We failed to build GLFW actually, so we don't even have the like the X11 environment, which is what it's telling us right here. So we need to copy this line and install it. And then I'll also make sure I add it to my Docker file. Okay. So once those are installed, we just reconfigure CMake again to give VC package a chance to build leftover dependencies. The cool thing is anything it does already build, it will you won't have to rebuild it. It'll cache it. Ooh, we got another viewbot. I've been on here long enough to receive 2 viewbots. Let's nuke that. Thou shall not suffer viewbot advertisers to live in stream. Let's see here. How do I get rid of you? Be gone. You've been rejected. Let's see here. Okay. All right, so it looks like we're making more progress. So I think installing those tools helped. It's like there's more tools coming up that we might need. Yep, there's the OpenGL drivers. It might yell at us. My cat is attacking me again. Little twerp. Okay, it's oh, maybe that's all we needed. Maybe we're good. Looks like everything's building. All right. We have successfully built our dependencies and configured our project, so let's compile. Ooh. All right, who here? C++ interview question. Can anyone explain to me why we're getting undefined references to these GLFW symbols? That's right. We've got a link against GLFW. So we probably need to do something like find package. Does it tell does the configuration tell us? I'm gonna run the CMake configuration again. So it might tell us. But I think it's going to be something like GLFW config required link against GLFW. It doesn't say, but we can make it tell us by making GLFW a first party dependency here. So we come in here to figure out what the GLFW dependency is called, which I think is GLFW3, ABCDFG, LFW3. Okay, so we say GLFW3. Cat, you're gonna have to wait. I already fed you. And I have witnesses. Okay, let's try to configure again one more time. And it should tell us. You're siding with the cat? Oh, no. Trill, I'm sorry. Oh, he left the room. Now I feel bad. All right, I'll be right back. You got me. All right, you win. He got food. He's happy now. Okay. So, okay, so now that GLFW is a dependency, it tells us how to find it, which is GLFW3. So that's really all I got wrong. So now we configure one last time. Oh no, I'm getting hungry now. I've been at this for 3 hours. Yikes. Explains why I'm getting hungry. It's exhausting, especially all the talking I did. I'm totally not gonna have my voice tomorrow. All right, so that built. All right, is this actually going to run first try? If this shows graphics on Windows through WSL in a Docker container, How cool is that? How cool is that? We now have an application compilable on Windows and Linux, on running on Windows desktop in a WSL environment through a Docker container running graphics, OpenGL graphics. Check that out. That's so cool. Now, do you guys know how that works? Do you see how, like, say that 5 times fast? Do you see how, like, clunky the resizing is? That's because the way WSL does graphics is it's essentially a Windows remote desktop window that is remoting into your Linux environment to show that, and it makes that application like full screen so that it acts like a window on like a Windows application on Windows. Draw that using Vulkan. Oh God, have you ever tried drawing a triangle using Vulkan? I've done it before. I went through the tutorial. There's like a C++ tutorial, and it was literally like 12 to 1500 lines of code just to get a triangle to render. I never really got past that point. That was some low level. Like you basically have to know how the GPU works to be able to understand what that code's doing. It was intense, and I did not put forth that much effort. Okay, so this works. Working hello triangle on Linux. And the best part, whether it's Windows or Linux, you can clone the project and build it the exact same way. You're just changing the different preset option. That's all you're doing. Everything else exact same. So now in a software pipeline, I could create a build matrix that specifies like platform and compiler, and then create all these different matrix build configurations to support all of this. In fact, I'm already doing that in my actual project that does all of this. So I have a project here. It's nothing like other than all the CMake stuff that I'm doing that I'm showing off step by step. It does the exact same thing, but more, because I support all these different platforms. And I do so via these build matrices because I'm able to configure them all the exact same way. And the best part is any like special edge case testing or Clang Tidy, any of these like side tests that I want to run on the code base, I also use CMake scripts to run. That way, anything that runs in a software pipeline also runs locally on my machine. But that's way beyond what I'm trying to do with this project at the moment. Okay, so we now have everything building Windows, Linux. So what's next? Do we do WebAssembly? Should we try and render the triangle in a browser? A browser is probably a little easier than Android. I can't do Mac right now. I mean, I have my MacBook, but I don't have anything set up to stream it, so I don't know how I would show that off. I'll have to when I make a YouTube video out of this, I'll have to record the MacBook steps separately, I think. This is taking a sec still because I'm in that WSL environment. That's still pretty cool that that works. I didn't even have to like forward my GPU or anything. It just blows my mind. I wish I would have had this when I first started doing software development. That would have saved so much time. WSL is so cool. Okay. So for WebAssembly, I am going to stay in the dev container for most of this work because it'll just be easier to keep everything like self-contained. I'll have Windows and then I'll have the dev container. So Windows, I build on Windows. And I also have Mac. Windows, I build on Windows. Mac, I build on Mac. dev container, I can support everything else because Linux is awesome like that. But to do that, we're going to need the WebAssembly toolchain, which is called Emscripten. And again, I've already done this, so I'm just going to grab it. Emscripten. And let's see, EMSDK version latest. I need all of this. So we just specify a variable so that we can, if we choose to, pass in a different version of the SDK. Otherwise, we're just grabbing the latest. And the way you do that with Emscripten is you just go to GitHub and clone it. I'm cloning it into /opt. We're setting up the Node.js executable as well, because, you know, WebAssembly, web, there's going to be JavaScript involved. And then we also need to set up the path. So that Emscripten tool is in our path. Compilers, that is. Okay. So that gives us our compiler tool chain. Is that everything I need? That might be all I need. That might be all I need. So, why WASM though? I'm not expecting you to use actual web tools like JavaScript, but I'm not sure what would be actual use case for this. That's a great question. I would say the main reason for WebAssembly is access to tools, libraries, dependencies that already exist as native code, C or C++ code that you want to use in a browser, right? Think of like really fundamental libraries, libpng, zlib, libjpeg, like the kind of the building blocks of software, right? If you need that to run your code, that's WebAssembly, right? Or maybe you just have like a massive code base where instead of rewriting everything from scratch, it's easier to just say like, hey, take your code, compile it WebAssembly, boom, now you have it running in a browser. You look at like the Qt framework, that entire thing is a massive ecosystem. And you just compile it in WebAssembly and boom, now you have GUI in the browser. And then why for me? Because it's fun and it's cool to see how it works. Because I never would have thought C++ running in a browser would be a thing. But I mean, at this point, it's been a thing for a while. Okay, so once the stuff is in the Docker file, it doesn't, like the dev container doesn't automatically get it. We do have to tell it to rebuild. So we will rebuild container. And we get to watch some paint dry. My favorite part of the game. We should see it, like, yeah, so some of the stuff it didn't have to rebuild, because remember, Docker's built in layers. Ooh, that's awkward. I broke something. Does it ever get old for you guys when you're writing code where stuff just breaks and you just want it to work? It gets old for me. Need to get better CPU. I've got a pretty good PC right now. I'm rocking the 9950X 3D. And I've got my stream set up to where it's like I'm streaming to Twitch, I'm streaming to YouTube horizontal, I'm streaming to YouTube vertical, which I don't even know if anyone's watching on YouTube. I don't think people have been. And on top of all of that, I have two 4K monitors, and so I have like in OBS I have scenes set up to render my camera in 4K, my desktop in 4K, and then I'm using the CPU to record everything in 4K separately so that I can, you know, go video edit all of this back together the way I want to present it. It's kind of cool. And I'm compiling. All right, so why did this build? Failed. Failed to build, failed to solve. Did not complete. Oh, I wonder, do I have a syntax error? Did I screw up? I might have a syntax error. If I have a syntax error, it is not obvious. Ooh, do I have Git? I have Git. Dude, Trill, what do you want? What's going on? Yeah, food. The garage door's open. You can get outside. What do you? You have water. It's failing to run my raylib command. All right, what's going on here? apt-get not found. Oh, this has made it to where I don't have. So do I need to install everything before this line? I've ran into this issue before. I think I do. Oh, or whoops. You guys didn't see that. Anyway, we're gonna reopen container and carry on. Turns out, if you remove all the paths in the path environment variable, nothing runs. Who would have thunk? What are you doing, Trill? You want us to come up? Come here. No, I'm not getting up. What? What are you doing? Come here. What? Come on. You want to come up? You want to come up? No? You're just going to be a twerp? All right. I'll be right back. Come on, dude. What are you doing? I think my cat forgets that he has food, and so he needs me to constantly walk him to it. All right, we are in the dev container. Do we have the EM SDK? We do. We don't. Actually, I don't even know if that's a command. I might be making that up. We have the compilers. That's good. So we should have EMCC, EM++ version. Yeah, there we go. Okay, so we do have the Emscriptum compilers. Good deal. Okay, so just like for Linux, GCC, Clang, Windows, MSVC, we need to do the same exact thing for Emscripten. which means we need to define a compiler. Preset. Compiler, new file, emcc.json. So we'll grab GCC as a template because they use the same parameters. Except we also have to add a special VC package chain load tool chain. So when the VC package tool chain is loaded, it will also include the Emscripten SDK. And this tool chain is provided by Emscripten. So that's what sets up all of the environment variables and stuff to find the compilers. Okay, so that's a CXX flag. We want a C flag. Oh, did I not have a C flag for GCC? Whoops. 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 There we go. Okay. Well, now I want to make sure I have it for Clang. I did not. There we go. Cool. Cool. All right, so that sets up our EMCC compiler. Now we need to set up our target, because now we're not doing Linux on Linux or Windows on Windows. We're doing Linux on Emscripten. So we call this wasm32 emscripten.json. So we can just copy this, paste it, and give it a different name. Target, wasm. And again, this is a triplet from VC package. So if we went inside VC package triplets, I think this is a community maintained one, but there should be a wasm somewhere, x64, x32. I'm blind. Right there, wasm32 emscripten. So that defines that. And now we need a platform. We need to define our wasm platform. I like saying wasm. Wasm. WebAssembly.json. And here, I think we're only going to have a couple builds. We can do x64 Linux. I think we'll copy Linux, paste it here, but we're not doing Clang. So we can get rid of Clang. We can get rid of, oh my God, these auto completes. Clang. Okay. So here our host is Linux, but our target is not going to be Linux. It's going to be wasm. Wasm. Our compiler changes too. We don't do GCC or Clang. We do EMCC. Pretty cool. All right. So now we have a wasm platform. We just need to make sure we include it for our presets here. and watch everything fall apart. What is going on? Invalid variable in preset. I typed something wrong. What did I type wrong? Upstream and scripting. VC package, chain load, toolchain file, cache variables. Platform modules, CMake toolchain file, that looks good. What is it complaining about? Do I need to reload again? Is this a reload situation? Might be a reload situation. Invalid variable, compiler EMCC. In preset, compiler EMCC. Invalid variable, cache variables. What did I do wrong? Version 7, configure presets. Have a name, compiler EMCC, hidden. Cache variables. VC package, chain load toolchain. What? What? Let's check a different file actually. Invalid variable, x64. Does this tell me where the error is? Compiler EMCC. That's what I named it. I have a plat. Oh, wait. No. x64 EMCC, compiler EMCC. All that looks good. Compiler. Target looks good. I'm gonna run CMake configure and see if it gives me oh, it doesn't even can't even figure it out because I screwed something up. Oh. Oh, wait a minute. I think I see what's going on. Yeah, I see what's going on. In CMake presets, you have to prefix the environment dereference with env. That's my bad. Let's reload. All right. Shall we, I guess, see if this generates a WebAssembly build? EMCC release. We'll see if VC package compiles Raylib for WebAssembly. Looks like it's going to. WASM32 and scripting. What do I want to eat? I'm getting hungry. Ravenous even. Hmm. All right, cat. I have fed you. I've walked you to your food. The garage door is open. You can go hang out there if you want. Am I just not paying attention to you? What's going on? Hmm. Weirdo. What sounds good? Mexican kind of sounds good. Kind of sounds good. Um, what do I want? Rice, beans. All right, where are we at? Failed to compile? That's not good. Um, Add library called with shared option, but the target platform does not support dynamic linking. Ooh, do I need to build this? Is that right? Do I need to build this as a shared object? I don't remember having to do that. What? Did I do that? I might have done that. I just don't remember. No? Let's see. VC package, library linkage, static. Um, Interesting. Triplets, WebAssembly, static. CRT linkage is dynamic. All this looks fine. I didn't change any of this. Yeah, I didn't change any of this. What is going on? Maybe I'm linking against it wrong. I need to look up an older example because I'm actually not using Raylib anymore. Dang it. How do I get to... just want to go to this commit. Don't actually know how to navigate. Oh, hello, Room Rocket. How are you? I'm in the process of getting some C++ CMake configuration to automatically build and generate WebAssembly so that we can render graphics in a web browser using C++. I mean, I've already done it before, but now I'm kind of walking through the steps because I want to try and make a video out of this as kind of a how-to. And I am in the middle of figuring out why my library is complaining at me. Add library called with shared option, but the target platform... Oh, so something else is trying to build the library as shared, but the target platform is configured for static. That's what's happening. But I don't know why it's happening because I've done this before and I don't remember... Oh, wait a minute. What's this? Android requires a shared library. Yeah, but that's not WebAssembly. I didn't think WebAssembly would require... Oh god, Ancient Fortran? I used to, how do I explain this? So, earlier in my career, I was working on a modeling and simulation framework where I had to integrate old... We're talking like, when is Fortran? Like 70s? Or at least this code was, like old 70s Fortran code that I had to interface with like the CABI with C++ code and having to like debug Fortran to figure out what's going wrong. I don't envy you. I don't envy you one bit. Ugh, Fortran. I have nightmares about that. All right, add library with shared option. Why am I getting this now when I never got it before? That's it. Programming is dumb. Everything's dumb. Oh wait, I was in the middle of ordering food and I forgot. I got distracted. Hang on. I gotta figure out what harissa chicken is. Roasted chicken, harissa chicken. Ooh, house-made chorizo. That sounds good. Chipotle honey. Cilantro onion. Pico de gallo? Question? Nah, I'll just do onions. Salsa. I don't want salsa. Don't need any of that. Okay. Let's do a bag of chips. All right. Perfect. Perfect. And the stupid app kicked me out. Oh, wait, no. It made it to the cart. We're good. All right, we're good. Fortran is fun. It's actually not that bad, though, having weird limits, like 72 character line. Yeah, that, yeah. It's that and, like, the limited variable length. I worked on a C++ code base that was ported over from Fortran, but all of the C++ code was still written with 6 character variables. That was a pain in the butt. Dear God. Nothing like trying to, and the problem is like, fortunately the guy who did the porting was around so I could ask him questions, but nothing like trying to decipher what 6 letters meant because the guy wasn't a C++ writer, so he just verbatim copied the variables over and he knew what the variables meant, but he didn't make them better. I have not seen this before. Add library called with shared option, but the target player. Did I do that? I didn't do that. I'm not building any libraries. What the heck? I'm building an executable. You jerk. So clearly, it's trying to build librarylib. You have a transpiler for your variable names? Hey, I wrote this tool to translate my variables to your variables. That way we can both work on the code base at the same time. I gotta review my. I've done this before, and I'm not seeing anywhere where I have. Okay, so if mscripten. Okay, so let me try this. I don't know if. I mean, I knew I was gonna have to do this anyway, but I was trying to wait to do this. But if we are on the Emscripten platform, we are gonna have to do some other stuff differently. Oh, I don't know why I'm writing CMake like it's C. End if. There we go. So we need to do target link options. I actually don't know if I need all this. Ooh, I might. Maybe that's my issue, actually. I bet that's my problem. Because I'm trying to link against GLFW that comes with Raylib. But for WebAssembly, Emscripten provides its own version of GLFW. So I think I have to link against it instead. Oh, I'm sorry. Is my cat down here? What are you doing, dude? What's going on? My cat's like rolling up around my chair and I'm going to accidentally like roll into him. What I do like and what I'm having issues with is that any mismatch between 32 and 64-bit floats won't compile, but the ancient code I'm working with struggles with it. Dude, isn't it? Wasn't it Fortran that like lets you compile when your function parameter list mismatches or something like that? Couldn't you have a function that's like, say, 6 parameters, but you call it with only 3 parameters and it still compiles? I feel like I remember that being an issue I had to track down because like legacy Fortran let you do that, and the code was written by a bunch of like electrical engineers instead of programmers, and so they were inconsistent with how they called their functions. That was insane. Okay, yeah, I'm almost certain this is what's happening. I don't know what ES3 is though. Allow memory growth. You know what? The autocomplete lets it. Maybe, you know what? Screw it. I'm going to let it. We'll set that to private. Let's be consistent with our formatting. I need to find a tool that automatically formats CMake for me so I don't have to do it manually. I am a huge fan of auto formatting. Even if the formatting isn't to my tastes, if I don't have to worry about it, sign me up. All right, so now what I'm doing here is making sure that my executable gets built with an HTML page. And then I also need to make sure that I can install all of the WebAssembly files into a single directory so that I can run it as a server, a web server, and access it in a browser. So I'm just going to copy and paste what I have here. Call it a day. I wonder, I don't know if this line's needed or not for Raylib. I think it's needed for SDL3, which is what my current project uses. So I'm going to get rid of that. And I need it. We'll put it back. Trying to get it to trying to get to work on G4tran. I remember that, which is stricter to the standard. Other compilers do a lot of weird stuff. That yep. Oh yeah, I mean it's especially when you're down in the weeds like that. It is definitely a lot of fun. I will agree with you there. I had to do a lot of debugging, but it was kind of cool seeing how these different languages could link together, and then like as I'm debugging, be able to like step into Fortran and then step into C++ and like back and forth. Now getting all that stuff set up so that I could step through it to debug, that was a pain. All right. That might solve the problem I was having. Let me make sure there's nothing else I need to do here. That might be it. Okay. Yeah, because I think Raylib needs to link against GLFW, but GLFW on its own is not a WebAssembly target because Emscripten provides its own copy of GLFW. So now if I configure, let's see what happens. Oh, you know what? I bet I also have to tell VC Package to not pull in GLFW if I'm on Emscripten. There's a way to do that, and I totally remember how to do it. Of course, it's not in my current branch. That would be too easy. Yeah, okay. I think, yeah, it's failing to compile. I think I need to disable GLFW3. How do I do that? I think it's something like... no, it's not feature. It's platform... not Emscripten? Question mark? Let's see what happens. What are you doing? All right, my cat is attacking my Ethernet cable, and I gotta address this. What are you doing, you little twerp? Get it. My garage door's open. He wanted out in the garage, so I walked him to the garage so that he could walk through it. Oh, I apologies. I probably could have grabbed him before I got up. I'll if he comes back in to attack me, which he normally does, I will definitely nab him up. His name is Trill because his purr is like really loud and really high pitched. Okay, so now I don't want to find GLFW. Okay, so I need to do it like this. If I'm in Emscripten, so I need to do like if not. Oh, I hear him. He might be coming back. Oh yeah, I hear him. Trill. Here, kitty, 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 kitty. What? I hear you. Come here. What? Come here. They want to see you. Come here. What? Say hi. Can you say hi? Hi, Trill. Can you purr? Mm-hmm. What are you doing? You have food. You have water. The garage door is open for you. There you go. Can you hear him? Yeah, you're a little twerp, aren't you? You're always attacking me and biting me. Yeah. Yeah. All right. Okay. You got hair all over me. Okay, so we don't want to link against GLFW if we are not. Wait. Am I doing that right? Yeah, if we are not emscripting. Something's missing. Okay, if we're not emscripting, link against GLFW. If we are emscripting, we tell emscripting to use GLFW, use its own version. So now let's try configure. Oh my god, dude. What are you doing? I'll be right back. He's attacking my rug. Can't figure it out. He won't use his words. He won't speak English. Okay, where are we at? Everything is breaking. Something else. I'm doing something else wrong. All right. It's time to bring out the big guns. We're gonna have AI debug my problem. See if it can tell me what I'm missing. We'll give it the entire context of the output here and see if it can figure it out. I didn't want to have to do this, but GLFW is, I forget what the graphics layer maybe. I forget what the letters stand for, but GLFW is the library that wraps all of the operating system code to create a window. So on Windows, like, you see VS Code here on Windows. If I open a terminal, for instance, you see my terminal. This window, that requires operating system code to create that window. And the way graphics work is you take this window, create a graphics context, and then you use the graphics context state to render to the surface of a window. And different operating systems have different code to do that. So on Windows, you have code. On Linux, you have code. On Android, in a browser, so on Mac, all have different ways of creating a window using code. So GLFW provides a wrapper around all of that so that you have the same API on any platform you're running on. But because I'm trying to get this to run in a browser, Emscripten, which is the toolchain for this, has its own version of GLFW, so I can't bring in my copy. I have to use theirs. So that's what you're watching me kind of fight through right now is getting all that figured out. Apparently there is a use static libs, raylib use static libs if we're emscripten. What? Is that true? Is that the issue? Config. Man, I don't remember having to do that before. It worked. I'm not gonna question it. Whatever. What I am gonna do is move this here and see if it will still let me. Otherwise, I might have to rearrange some of this script. Let's configure. Okay, yeah, that's what I thought. It didn't like that. So I have to set this before I find it. What do I want to do here? If in scripting, use static lib. So I need to move all of this down below. Raylib, all that looks good. You know what? Now what I can do is actually move this to an else. Okay, let's try that. I do machine-specific compilations, so the operating system, etc., is known and defined, and it's not graphical, so I'm not... Oh, gotcha. Gotcha. Yeah, I'm not... I haven't done too much, like... I assume you mean, like, embedded work, right? You're not necessarily working for, like, an operating system. You're just trying to, you know, use whatever platforms, compilers they have to get it to compile to, like, the hardware you're running on. I haven't done too much of that in my career. I've done, like, for school, I've done little, like, Arduino boards. But that's about it. Ooh, okay, that looks like that worked. All right. So we need to actually set the install target here, since I did specify that I want to copy all the WebAssembly files to a specific directory. So let's see if this compiles. And it blows up. No, you work on a HPC system, so supercomputer. Oh, hi, okay. They have a defined... Oh, okay. Gotcha. Oh, no. Raylib still needs GLFW dependencies. All right, I gotta find my commit history because I have literally done this before. And my cat's back. I don't get it, dude. I even gave you more food. Let's see here. Okay, so how do I... What's this button? Oh, maybe this is what I... No, these are branches. But I might have some old code on these branches. 2 weeks ago? That might be good enough. Nope, that's for Android. It's not WebAssembly. Okay, I link against Raylib. Ooh, I wonder if I have to link against threads as well. I tell Inscripton I want to use GLFW3. They syncify. Yeah, I don't set the use static Raylib anywhere. Yes, I am United States, yes. Okay, I'm doing this. I only link against GLFW if I'm not Inscripton. Okay, so let me try not doing that and just doing this. There we go. Now we're cooking. All right. So in our build folder, under EMCC, there should be an installed web folder with our WebAssembly, JavaScript, and our HTML web page. So now what I can do is in VS Code, I can grab the live preview extension, install in the dev container, and add it to the dev container. Let's add it to the workspace recommendation. And all right, are we about to first try this? Come on. Don't you embarrass me in front of a viewer. First try, come on. So we come in here. We go to where we built and installed this, which is in this install web folder. Right click on the HTML page. Show preview. Don't you screw this up for me. Boom. We have our Triangle, Hello Triangle application running in a web browser. And then if we wanted to customize the web page and not use Emscripten's default web page, we could provide one. But look at that. Heck yeah. And we got console output for the browser, so we can still debug it all in C++ using VC package and CMake. We get to configure our projects, whether we're building on Windows, Linux, or in a browser. We get to do it the exact same way. And that is all baked into my Docker file, so now anyone who clones this project gets it. Okay, so I think we're at a spot where we can commit. Actually, I do want to figure out if I can get away with not setting this variable now. In the strongest form in its glory. Goddamn right. So weird that I need this. I did not need this in my projects before. All right, well, I guess I'm just going to leave it there for now. Okay. So let's commit these changes. Working Hello Triangle in WebAssembly. We're almost done here. I think the only other thing I need to do is get this running in Android. Because I can't really do it on Mac right now because I don't have it. I don't have a way to stream it. But I'll have to do that later and record the screen so I can make a video out of this. We'll see if that video turns out good. I'm not a good video editor. Mainly because I haven't practiced. Let's see here. Is that pushing? I don't remember if I hit that button. I didn't. All right, so push changes. I don't know if I can show you. I'll have to be very quiet. He saw me. Dang it. Never mind. He saw me. He was starting to fall asleep. Okay. Just realized, nope, I think we're good. Okay. So that's pushed up. So now, the final piece of the puzzle, I think, is getting this project compiling on Android. So what does it take to get C++ with a Hello Triangle running on your device? Since we're on Linux, we'll start by modifying our Docker file. So we have our Emscripten dev environment. We now need to set up our Android dev environment. And I will be borrowing from my main project here to do this. But we are going to need the Android NDK, which is the native development kit. So Android gives us its own Clang compilers to use to compile code to support the Android platform. Let's see here. I need this. Oh my god, I need all this. This is actually kind of complicated, setting up Android. Oh man, I need all of that. Jesus. Need a lot. Boom. Wall of text crits you for 500. All right. So to support emulation with an Android virtual machine, we need to install these tools: libpulse, libgl, composite, cursor1, xi6, stst6, etc. We need to point Java Home to the Java 17 OpenJDK, which I think we installed up here. Which I don't really need to. I can install that down here. I don't know if I want to do no install recommends. So we want that. We want USB utils. Okay. So then we specify Java Home. And then we go and grab the Android Software Development Kit. We get the latest version. We're going to uncompress it, extract it, put it in opt Android SDK, specify Android Home. We're going to make the directory. We're going to grab the SDK manager and use it to install additional Android build tools and platforms. We're going to create an Android virtual device, and we're going to call it, what are we going to call it? Pixel. Using Pixel 6. And then we set up the native development kit, which comes with the C++ compilers we're going to need. Specify the NDK home, and then we need to set up our environment variables. Which becomes this. I think that's... But we need to set up a debug key store for Android. So we don't need to do extra setup to do some debugging. Okay. And then with all of that, we need to rebuild our container and see what happens. See if I got this wrong. Rebuild container. So this is going to go out and grab all the tools we need from Android, get it installed so that we can build C++ on it. Oh, yeah, you're right. And that's probably, and I'll have to clean that up. That's probably why I'm having to run apt update every time, because I ended up removing the cache. Well, so I don't know how familiar you are with Docker, but part of it is with Docker, ideally, now this is a toy project, right? So I don't have to be like super optimized here. But with Docker, each of those command statements that I'm putting down, those run statements, they are their own layer. So any temporary files that are left over after a command is ran, they are in that layer. So even if you clean stuff up afterwards, you did not clean them up in that layer that was built. So that's why, like, doing an apt-get update, install, and then remove keeps that layer just a little bit smaller. That's all that's happening there. Yeah, you're not, yeah, you're right. Yeah, you don't really need to remove it. You're right. You're absolutely right. And even like professionally, when I've worked on Docker files, I don't think I've ever removed it. But to be fair, I also didn't realize like some of this, like keeping stuff small like this, I didn't realize everything I could do to make that happen. So part of this is just learning. I'm just playing around, seeing what works, see what doesn't. That's what this is all about. Just trying stuff out. But yeah, saving 8 megabytes isn't going to make a difference when my container. I think after this Android stuff is installed, my container might be like 16 gigs on disk. My food really needs to get here. It's close, close-ish. I need to get like a cat cam or something like that. On HPC systems, we use Aptainer, compatible with Docker. Don't want users having root. Yeah, I I'm not familiar with Aptainer, but we for security purposes, I've been in like classified environments, right, where you really don't want users having root. Probably the same reason you don't. Uh, and so we ended up having to move away from Docker because it didn't really, at least at the time, it didn't really support non-root use. And so we ended up using something called, I think, Podman. I I I wasn't really involved as much because I was more the software guy, so I was more about writing the code. I just had to be aware of like what my software was running in. We might be getting into the container, which means we have the Android NDK. And if this works, I will load this on my phone and hopefully be able to show a triangle. Okay. So, where do we even begin? Once again, we need to set up our CMake presets to support Android. Oh boy. Am I really gonna have to use this? Gosh, I hope not. Might have to. Preset compiler. All right, so our compiler then is going to be the Android NDK. Which really should just be Clang. Ooh, but it's going to have a different toolchain file. Toolchain. Is that what I want to do? Yeah, I kind of want to do a chain load. Let me try. Um So what I want to do is Android NDK home. Build CMake Android. Yep, that's what I want. So I want to chain load this toolchain file. Container has more HTTP stuff like read-only images. Clustered file systems require some different limitations on how images should be. Not doing any March or MTune is weird. Pretending to be 2006, yeah. Can't snort. Let's see here. Okay, so I've set up the Android toolchain. I think that's good. Reset compiler host. Okay, so now we're still building on Linux, so the host doesn't change, but we are going to have a new target. That is going to be ARM, because my phone is obviously Snapdragon, so that's an ARM processor. Android.json. What does this target become? We need to look for a triplet. It's ARM64 Android. That looks good. Okay. Then I think we need to create an Android platform. Android.json. Oh boy. We'll just copy WebAssembly in here, except instead of EMCC, we use Android NDK. And our target is ARM64. So then this becomes Android NDK, compiler Android NDK. Okay. And then in our CMake preset, it should just be a matter of Android. And of course, there's errors. Could not find configure preset compiler Android NDK. Ooh, did I not name it right? Or did I not include it? Compiler Android NDK. We didn't name it right. Platform, did I include it right? Compiler Android NDK, Android NDK. Oh, that looks good. Compiler Android NDK. Okay, let's do a reload to see if that fixed our issue. Good night, Room Rocket. Really appreciate you hanging out. I really do. It was nice chatting with you, especially someone who knows Fortran. All right, let's see here. We are almost there. Did that configure? Oh, it configured. Okay. So I can Android NDK release. See if this works. Food is almost here. Just in time, if this works first try. I'm still going to have to install the bundle and also install an APK, so I will have to figure that out. Ooh, I'm almost certain I'm going to have to link. Um, also going to have to set up my project to build as a shared library if we are on Android. If Android, else, and if. Like that's needed, that's required. Okay, let's try figure now. Okay, I'm screwing something up here. Maybe I shouldn't define... Maybe I shouldn't define that. My food's here and I'm so excited. I couldn't hide it. I don't know. Might still be doing something wrong. But that's okay. My food's here. And that's what's important. I'll probably get up and get it here in a second. So what am I doing wrong? I gotta find... Okay, so for Android, if in scripting, we link against GLFW. Do we link against? Let's see, graphics. Okay, yeah. So for Android, I got to link against a bunch of stuff actually. So else if Android find library log lib log find library Android lib Android find library GLES v2 lib find library BGL target otherwise we link against GLFW. Okay, so we're not linking against GLFW on Android either. That makes sense. Okay, so we don't link against GLFW, but we do link against these libraries. All right. Oh, Android. Oh, I never set my platforms. I think I set them here. CMake, Android, preset, compiler, Android. Yeah, here we go. Okay. Android Platinum not set. That's a lie. All right, let's cancel this. Let's reload. Configure. Am I doing that wrong? Invalid. Let's try this. Does that work? Configure. That might work. So if not in Scripton and not Android, we use GLFW. All right. I think that's working for at least a brief second. So I am going to go grab my food real quick. Be right back. Be right back. Ooh, it configured and generated. Does it compile? It does not. Because it doesn't have an install target. Which is fair. I didn't give it one. So let's give it one. So if, let's see, Android and Scripton. If not in Scripton, we do this. Let's try that. There we go. So we got a shared object compiled to run on an ARM platform for Android, but that's not enough to actually get it to show up on my phone. We have to bundle this into an APK. And to do that, we're going to need Gradle. I don't remember. If I'm gonna need to pull this stuff in. I don't remember how to. I could probably just. I know what I can do. Hmm. Hmm. Do I have Gradle? I don't. Think I'm good. Does Gradle come with Java? Is that what I'm missing? Hmm. Yeah, I don't know what. I don't know where the directory of my. Oh, I guess I can just do Java home, right? Okay. So I need to export path equals path colon Java home slash bin. Hmm. I don't see Gradle in there. Whoops. SDK install Gradle. Doesn't seem right. You surrendered more money to OpenAI? Oh no. It's addicting, isn't it? Okay. I have Gradle now. Oh, build successful. Wait, what? You didn't build anything. Weird. All right, so I need to make sure my Docker file has Gradle installed. Okay. That's okay, right? Because you can have AI fix them for you. Okay, now that I have it installed, I need the wrapper. Let's see what this does. Okay, there's a .gradle folder. Cache output bin. What is all this? There's a Gradle folder. Okay, okay. No perfunctory. I don't want popularity. I want to be hanging out, coding, and be chill. Be gone. I banish you to the shadow realm. Nonsense, acting like I need viewers. I've got a full-time job. Oh, I see. That's fair. Oh, I think I see what I'm doing wrong now. I don't do this here. I do this in my Android folder. Okay, so basic Android structure is an app folder, source. Oh, I create a file. In this app folder, we need a source folder followed by a main folder. And in this main folder is an Android manifest.xml file. And inside this app folder, I need a build.gradle.kts file. Do you want to install the recommended Gradle for Java extension? Nah. Okay. Then I need in my Android folder a .git ignore to ignore all the temporary build files for Gradle. I need a settings.gradle file. No. I need a build.gradle. Not there. New file. Oh, maybe it does it. No, I already have that. I need it at the root level. Okay. I think I needed to do that. And then I change into my Android folder. When invoked via the CMake APK, target build directory is passed as a Gradle project. God, this is so complicated. Everything is so complicated. Why you gotta be so complicated? So I think I'm just gonna copy and paste. This isn't working. Oh wait, did I do this wrong? There we go. Okay, this gets a little more complicated. Holy moly. All right, so this is using an old toolchain file, which I don't think we need. This should just be the VC package toolchain file. So root directory, parent file, absolute path, replace. So this just becomes the VC package. So we have target triplet, host triplet could be Linux or Windows. So we're using the APK to build our project using CMake. And then it's going to build a bunch of commands. Don't need any of this. Don't know. I guess let's make sure that the project is built if we try to build the APK. So I guess that's okay. Okay. So now I think I need the Raylib code. I might have to use some AI help here because I honestly don't know what I'm doing. And this would take all night to figure out. Because I think Raylib should have some Android code that we need to pull in. 2019 Android. There's a native activity and a packaging. It probably comes with all the properties and stuff I need. Okay. So I'm gonna copy relative path and I'm gonna be like, hey, I need to set up my Android folder to support building an APK from my installed project. I'm using Raylib for rendering. Well, that didn't work. Copy path. I believe it has an Android project in there to build. It's located here. Can you review my project and verify and fill in any missing pieces to make this work on Android? For instance, I think Hello Triangle app might need to link against the, is it native activity? Native activity. Activity. Thanks. I don't need to say thanks. What am I doing? What am I doing? All right, cat. What are you doing? What? All right. Well, I guess while I'm waiting for AI to do its thing, I'm gonna see why my cat's being a jerk. Hey, where are you? I don't want to hit you. Let's go. I feel so bad. My cat wants outside so bad, but I can't. He will slaughter all the nature out there. I would feel so bad. To a place I belong. All right, looks like it's looking at all the stuff I've done so far, so that's good. Clear picture now. Let me check what's available in the dev container and then fix everything. Oh, it's going to fix everything. Stage my changes so I can review the changes the AI makes. Wait, what? Okay. Mountain Mama, take me home, country road. All right, now I have a full picture. Let me enumerate what needs fixing. So updating the Android manifest, that's good. Now we need a strings.xml resource, of course. Where's it putting all this stuff? Strings.xml, what is that? App name, hello triangle. Okay. Totally would have known that. Now fixing build.gradle, the target name is wrong. System Gradle is too old to parse the settings file. Let me create the wrapper files manually. Uh-oh. What? What version of Gradle do I have? Gradle 441. What should I have? See, installing Gradle. Install with a package manager or install manually. Oh, they're on Gradle 9. I have done this horribly wrong. Oh, no. Download the latest Gradle distribution. Contains in 2 flavors. Okay, so I've gone down the wrong track. That's why you can't always rely on the AIs, but I can rely on the fact that it told me it had to. See, it went and made this work for 4.4, and I need to make it work for 9.4. So where did I install Gradle? Because I can't do what I thought I did. Right here. So I can't do this. Actually, let's see where we're at. I guess I'll just let it finish and then tell it to fix it. I'm using Claude Opus at the moment. I installed Gradle via Ubuntu's package manager, but it's 4.4, and when I went to GitHub to look at the Gradle version, they're on like 9.4. And so the AI is like, oh, well, you installed 4.4, so you know what you're doing. So I will make your project work with 4.4. But 4.4 is like super out of date. Look at this. Build time is 2012. That ain't right. Yeah, I have I'm using Copilot, so I have access to a bunch of them. I have access to all of these. At least with coding, I've had the most success with Claude, but to be fair, I haven't tried the GPT codexes at all. I definitely haven't tried Grok. That's not true. I've used GPT for other stuff. I just haven't been using it for coding. My cat, I swear to God. I can't let you outside. You will kill all of the life. All the birds will die if you are let outside. I just tell you are a murdering machine. Just tell. All right. All right. Main account. It's GitHub. I just purchased it through GitHub. Purchase it through GitHub, sign in, and you get so many minutes. All right. Here's the deal. I screwed up. I installed an older version of Gradle. What really needs to happen is the Docker file needs to download and install the latest version of Gradle, which is from is this it? Binary only, complete. What's the difference? Binary versus complete. Yeah, I'm going to download it and find out. Oh, Install the latest version of Gradle from here. Okay, let's see what it does. Cost efficient? I'm not sure. I honestly don't know. Because I don't know better, if I'm being honest. I got it through GitHub to start with, and that's what I've been using since. Okay, so it is now doing Gradle version 8.14. Is that like the LTS or something? It's better than what I was using. All right. Note, Gradle 941 is the absolute latest, but AGP 873 requires 8.x. If you upgrade AGP, you can bump Gradle to 941. I don't know what AGP is. Android. What is AGP? It is the plugin Android application library that makes Gradle understand Android projects. Compiling in your project this line. All right. Let's get Gradle 9.4.1 installed, and let's update the Android project to support it. Is that it? Is that all I need? Okay. Guess, what do I do next? Try and build it? Oh, it's still going. Okay. So let's make sure my project still compiles, which it should, because I don't think I touched it. Using Android NDK. Okay. So that compiled, but we still need to build the APK so I can load it on my phone. Okay. I built my Hello Triangle project. Can you now build the APK and ensure it is ensure it is copied to my build preset name Android. Installed Android. 1 second. Okay. So it built them. Before I tell it, because I'm going to have it make a CMake script to auto handle this for me. So installed Android APK release. Awesome. Okay. So let's try and get a Hello Triangle running on my phone. And see if that works. What's this? Make platforms, build, NDK release, installed Android APK. Copy. Paste. All right, let's see if I can install it. Allow. We go to files, ABCDEF, files, downloads, APK release, install, scan for viruses, install. Hello Triangle was installed. ABCDFGH. We have Hello Triangle. I don't know why it's horizontal, but we have it. Is that an Android manifest thing? See, Android theme, no title bar, full screen, orientation, landscape. Yep, it needs to be portrait. Portrait. Okay. All right, cool. So now the last step of this puzzle is instead of relying on like AI to build the APK for us using Gradle, we can make a CMake script to do it for us. And I'm going to put that in CMake. Oh, all of these were supposed to be in a preset folder this entire time. Oh well, too late. I'm gonna make this build apk.cmake. Can you implement a CMake script I can use as a build target to build my project as an APK, making sure the APK is copied into the CMake install prefix / Android. Okay, so if not Android, warning, blah, blah, blah. Android not set, skipping APK target. Project root, Android project directory. Gradle W. Make the Android directory. Oh, in the install prefix. Debug APK target, APK debug. I don't know if I need both of those. APK release. Will it build debug for my release build? Is that how that works? Yeah, assemble debug, assemble release. Huh. Maybe it will. Fair. Totally fair. I am almost done, I think, for the night. I just need this to build and configure successfully. I'll verify it works on my phone again. And then that will be Hello Triangle on Windows, Linux, WSL Linux, Android, and the web app. And then I'll have to record another video on my Mac to show this working on Mac. And that should be enough footage to maybe try and make a video. Or pay someone to make a video. Haven't decided. I am exhausted. I'm just petting my cat. Okay, so now we have a build APK. Target APK debug release. All right, let's try it. Okay. So now I should be able to I'll delete this installed folder. Should be able to build both a debug and release APK. Oh, someone messaged me on YouTube, but it never came across in my OBS. What the heck? Or I missed it. Oh, I see him. Okay, I just missed it. I get distracted by all the setup I was doing. I was having too much fun. Okay, so that Gradle wrapper not found. Build successful. Okay. Installed. I have an APK. I have a debug and release. All right. So one last test because I also changed it to be portrait instead of landscape. So this will tell me if I actually like got it compiled correctly. Okay. I am just navigating my file directory here into my, what is that? Build, Android NDK release, installed, Android. I'm going to copy the app release APK. Excuse me. We'll paste it. All right, so app, let's try this. Files, download, app release APK just now, update, scan the app, install. It was installed. All right, so if this worked, I should now have a portrait hello triangle. Boom! Hello Triangle, running on Windows, running on Linux, running in the browser, and finally, running on Android. Let's get this committed. I also wanted to make sure my CMake script was good. Not that one. That one. All right, that looks right. That looks correct. That looks correct. Okay. Hello Triangle running on Android. All right, that's not bad. That took me 5.5 hours. Oh my God, I've been streaming for 5.5 hours. Are you kidding me? It took me 5.5 hours to go from scratch to a solution that lets you build C++ projects on any platform. Obviously, I'm not supporting all of them right now, but I showed how you can via the CMake presets. I'm pretty happy with that. Is there anything else? I think that's going to be it for me. I think that's a good stopping point. That gives me enough video to try and make a how-to. I'm still planning on recording and showing this in the video for Mac OS on my MacBook using ARM. I might show dev containers working on the MacBook too, but that requires Docker desktop, so that might be out of scope. I'm not sure. We'll see. For anyone who's still out there paying attention to me on Twitch or YouTube, I really appreciate it, and thank you for coming by, and hopefully I will catch you another time. Have a good night.